Alrighty, hi everyone. We're going to look at the Zig language today. And I thought I prepared a small thing that we're going to try to implement. Right, so let me first set everything up. Okay, let me check if we're indeed online. Looks good to me. Yeah. So what about here? Yeah, also looks good. Okay, perfect. Alrighty. One small second. Let me start. C line. So Was that perfect? Okay. Let's try this out. So we want a new project. We will call that first it's a zig project, and we will call that, let's say, random gradient effect. So we got nothing, so we need to download zig. 0.17 def, I don't know. Sure, do it. Okay, so name is that, path is here, toolchain, path okay, let's add it. Next thing, I think that's the zig language server, right? So let's go ahead. Yep. Perfect. Add this as well. So zig project template generates zig using zig init. Sounds good. Smart indent maximum file size. Smart indent maximum file size. I don't know. We got alternative or standard. I don't know as well. But what we can do is we can open the zig plugin source code on the side. Let me quickly set this up. It will just take 1 second, I think. We're going to need IntelliJ like this here. Okay. Open. Where is that? I think I saved that under temp ZigBrains. So there are several plugins. I just used the one that has the most downloads and upvotes. Perfect. Yeah. Okay. This window. Yeah. Okay. Got that. Thank you. Okay. I can switch back. There you go. So that's the plugin. Let me say something like zoom. Give you something to watch. We don't need the Gradle tool window for now. Okay, let me see. How's that on screen? Should be okay, right? So we got that, and we got C line here. So smart init and commenter. So the commenter is standard or something. Um, what I'm going to do on the side is just look basically how the things are. So here we got comments. So thank you for closing down. Okay, it's still analyzing the project. Okay, okay. Go ahead. Take your time. We got all the night and it's almost weekend. So we're good. Okay, so we will come back to that here. Let's use standard for now. I need a tissue. Create. Would you like to open the project? Of course. Don't in, let's say, this window. Okay, nice. So it got a main, it got a root, it got a build zig. So I know nothing. And that's okay. It's kind of like, of course, I know zig for a long time from the name, and I read a bit on their documentation page. So I know that the build files are essentially zig code. I think it's not entirely complete zig code. There are some things, some config stuff that is extra, but I will have to lie. But we'll find out. Oh no, it's the zon files, exactly. It's these files that I was stumbling over when I looked through the plugin, the zig plugin implementation. Okay, so this seems to be some kind of struct. Change in this has security and trust implication. Tracks the earliest zig version that the package considers to be a supported case. Okay. Yeah. All right. Before we dig into that, I must not forget that I wanted to enable some of the chat commands as long as I don't have the plugin I'm working on. So let me see. I think I need to do that kind of bit of without, so I'm not sure if there's something that shouldn't be shown on stream. Better be safe than sorry. Okay, so let's head over to Restream. Channels, analytics, clips, past streams. Wasn't there something like, okay, channels, storage clips. Maybe settings, backup, bad chat, customized chat maybe. Notification, reply commands. Add pre-made messages like welcome or your social handles to appear in chat. Only the streamer can trigger the commands. Okay. No, that's not what I was after. Oh, maybe I am. So we got notifications. Enable text to speech. Can I do that? Choose how you're alerted to new chat messages. Okay. Voice. I think English, right? UK. Female, male. Read nicknames, sure. Do not read links, sure. Yeah, read emojis, it's good. So let me see if that works. Ooh, I didn't know I can do that. So where do I have the chat? Wait, I need a...
Enraged ambush of JG. I viewers streamable. Com.
Okay. Yo, so you circumvented my do not read links by putting a space after it. Nicely done. I guess you're a bot, right? Okay. The voice sounds a bit dry. We definitely have better voices, and we will implement them. Maybe tonight. I'm not sure if we managed to do that tonight, but basically everything is set up in the other project that we were trying out. So I can catch chat messages there, and I can make just enable text to speech with really crazy, nice, and very exotic voices. So wait, I launched chat here, but I only see chat. How can I react in chat? So I do. Okay, so I guess I do have to see that here. Okay. Mm, so hello everyone, welcome to the stream. And I need to see. So I don't have desktop audio on, but I got it now. Let's send the message. It's not reading my message, is it? So it only works when someone else writes. Okay, so let me check that here. Oh, where's my channel? There's my channel. Crazy. Okay, so is the TTS working?
Halarutan. Is the TTS working?
Yeah, the TTS is working. Okay, and I wanted to check the level. The level should be okay. How is the sound level of TTS?
Halarutan. How is the sound level of TTS?
Perfect. I think it's good. Notch it a tiny bit down. Perfect. Okay, and now we can go back to where we were. So let's see if in the meantime IntelliJ is done. Perfect. So we wanted to check what the commenter is doing. So what was the shortcut for hide all windows? Control Shift and F12 like this. Okay, then let's open that again. So I think this is a multi-module plugin. So you see several modules here. There's a core module, language, C-line, okay. So I think we're interested in core right now because we wanted to see what the difference is between a standard comment and alternative. So Zig Brains core. Zig comments config. Zig commenter editor service state holder. So Zig commenter data holder, Zig self-managing commenter. I don't know. Let's see. What's going on here? Oh. Get documentation, command line prefix, override font. So something's not okay. I'm not sure why, because if it says override, it overrides this one here. Oh, I got it only as class file. What's that? Platform core. Okay, download sources. Let's see if that works. Can I now open that here? All right, so self-managing commenter. It's a commenter that may provide a complex commenting logic. For simple wrapping, prefix may not be enough. Okay, use commenter. Okay. So something's still off here. So if it highlights string as red, something is not good. Let's see if we, okay, run with LSP, run, okay, so no, we don't want that. Let's, nothing to show. Ooh, that's not good. Okay, so that looks better. Still red. But what if we say build plugin? Is that working? Looks okay to me. Okay, so now we can say something like Gradle run IDE. Okay, so it starts C-line. It's here. And if we go to plugins installed, yeah, I got that. We should find ZigBrains. So that should be okay. So it builds. The question is, why is highlighting not working? What does it say? Cannot resolve symbol. Weird. Okay, so let's try to fix that. Cache recovery. Yeah. Okay, rescan. No. Not everything works. Nope. Still red. Nope. Still red. Okay. Let's go ahead. Re-index the whole thing. Exception idea core. should not happen. That project has seen file ID in orphan queue at index larger than number of files that orphan queue ever had. Okay, that sounds like a highly specific error. So it's still not okay. Well, if it wasn't in the middle of the night, I could ask Jacob and Robert if that's something to do with the Gradle plugin, but I don't know. Let's make a final invalidate caches, everything, yeah, and restart. So we should be on roughly the latest version here. June 3rd, 10 days ago. Okay. Let me see. Oh, I can mute myself. No, that wasn't it. No, that wasn't it either. Like this. Yeah, sorry, I had a cough. What does commenter data holder have? Inland and state. SIG commenter state. Standard and alternative. That's what we were after. So where does it say, does it access anywhere here alternative? Or maybe I can just go here and then go here. Okay, so SIG self-managing commenter. Let's look first online. So who has this white space stuff? Show white space. Yeah, that's okay. I can do it like that. So we got here. That's the function comment line. Okay. So if the state is standard, then what are we gonna do? Document get end of line offset. Is empty line, okay. Append, okay, so in alternative mode. Wait. I think that is clearly Zig, right? That is clearly Zig style. Some run from, or is it? No, it's not, right? It should not be, because I think I read that you must not have variables that you don't use. And this is clearly unused. I'm not sure. Can do it like that. No, That's Python. How can we do that here? Remove, replace for each function. Yeah. Okay, so it appends. So comment line should be the easiest thing, right? Because it just comments out one line like this, if I do that. So line and offset. So if comment offset is bigger than line and offset, and is line empty, then we do something probably we don't. Okay, so if it's not, here, that's what I wanted. Append comment. And this is just a double slash. Okay, so the alternative is if line is 0, then it's a top level comment. That means what is top level? It's like this. Okay, it's a bit like how is it called? Doxygen? Is it? And C++ style, I don't know. So and else this detect line comment type. And then we insert a certain prefix. Okay, so we determine okay, so if we cannot detect a comment in the previous line, right? And we don't know actually if the user, for instance, I don't know, prefers maybe 5 slashes, right? Then we use the normal comment, and then we just insert this prefix and the white space. So, okay, if I got that right, so that's the first thing we try out. This will take ages, but right, what can you do? So we're here. I mean, we got standard, right? So if I comment this out, then let me turn on, just for the sake of brevity here, that let me turn on the how was it called? It was called the thing that shows the shortcuts. I think it was in settings. It wasn't called shortcut. It was something. Presentation assistant. Here you go. Okay. Display board. Okay. Apply. When I do that now, nothing shows up. Why is that? Oh, there it is. Key maps, Windows. Let's put additionals here. Display for, I don't know, 4 seconds. Okay. Pop-up size, bottom center. Perfect. Apply. Okay. So, but it doesn't show if I press that or this. Why is that? So that's Control / and it's not recognized. Okay. So if we go here, shortcuts for macOS are not shown. I need to install the plugin. Okay, let's do that. Okay, it shows tab, but it doesn't show the real thing. Okay, so it inserts two slashes. So if I, however, have this here, oh, I'm not even allowed to do that. What? What does it say? Found a documentation comment. Okay. So this is coming from the language server. Okay, well, we don't care right now. It still puts I two slashes there. Let's see. It's probably not here, is it? If I can do that on a project basis. So it's not here. It's not here because that's how it's built, right? So what else we got? We got zig cache, seems to be something other. Zig notifications. Settings. Okay. Toolchain config. Open toolchain configuration. No, it's probably project based, right? Okay, no, that's not what we wanted. Here. So now let's use alternative. Apply. Okay. Oh, there was a file, but it's now it's gone. So, okay, it does that. I think I'm not allowed to do that, but what happens if I, so see, okay. So that's basically what we predicted. So if alternative commenter is on, which I'm not sure why this exists, but it's obviously fine because many languages have different styles of comments, and there are, I'm curious that there are no word wars about commenting style. Okay, perfect. So we got that. So, right, so we got a build file. We got a zon file, which seems to be, I don't know, something like a configuration. So this is the default name used by packages depending on this one. For example, when a user runs zig fetch -- save URL, this field is used as the key in the dependencies table. Although the user can choose different name, most users will stick with this provided value. Okay. It is redundant to include zig in this name because it's already within a zig package namespace. So what I'm not sure is if it's okay to have camel case here, or if, I don't know, right? If the convention is something different, but we can look it up. Let me open a browser window. So here we go. Let's look up. So zig package naming convention. There you go. Sigitdaf. So is a specific reason it's discouraged. What's this? Okay, use of the name zig. Okay, so yeah, that's clear. New package hash format. All right. No. So it is obviously not like I did it. It is okay. But a Zig build system does not only support package in Zig code, but also C++ and so on, any other language. If your package is a set of bindings for library, let's say libfoo, and what sets your package apart from the upstream project is that it provides bindings for the Zig language, as opposed to just packaging the upstream project. Then a package name like zipfoo zig is useful and makes sense. Just like a name like libfoo minus rs or libfoo minus cs for Rust or C# bindings. Perfect. So maybe we should just look at, I don't know, Zig packages online. Zigstree. Okay, here we see. Okay, right. So it's always, so it's not camel case at all. No capital letters in there at all. And a heavy use of a dash. WebSocket.zig. Okay. So let's see. Can I rename that thing? It seems I can. So let's do random gradient effect. Element cannot be renamed. Okay, so the question is, why can't, I don't know, maybe it would need to have renamed everything, like the directory in which it is in. I don't know exactly. So maybe, and that's not trivial, right? I think I cannot simply rename the directory from within here because the project is open and so on and so forth. Okay, so let's forget about that. So version is 001. We keep the fingerprint. So this is tracks the earliest Zig version that the package considers to be a supported use case. So here we got dependencies, and I think we need that in a second because what we're going to do is do something graphical, and I thought we try several new things. So we will implement the stuff for calculating what we want to show by ourselves, if we manage to do that. And then we will use raylib Zig or Zig raylib or whatever this is called. So the C library, is it called raylib? Yeah, this one. And we will use the Zig bindings. So let's search for raylib Zig. Oh yeah, sorry. Here we go. So it has a commit from last month, so it should be fine. Perfect. We got a simple thing, and in the end, I think the only thing we need is a while loop that just displays a frame. We don't need to go crazy there. Okay, so and here it says how we can do that. So the thing is, so now that's the next thing. How do I install dependencies? Do I just add them here with URL, or do I run it in some special thing, or do I run it on the terminal, simply doing Zig fetch? Let us try that out. So we got Zig file. Maybe so it's not here because that is, I think, is that project level to the current project. Okay, so tool chains, languages and frameworks. Okay. Okay, so I think this is, no, we don't want to add another Zig. We don't want to override the standard library. So, okay, obviously it's not here. Let's, terminal is, I will never ever remember. So do we have Zig? No, we do not. So we don't have a terminal although we have a tool chain. Although we have a tool chain. Okay. What is the official, I don't know, Zig installation say? Getting started. So I think we did a direct download, and then okay, so that's still Windows, is it? Installing Zig direct, setting up path on Windows, setting up path on Linux. Okay, so they expect me to add the path. The question is, shouldn't it, right? So when we have for instance Python, and I'm working in an environment, then and I open a terminal, then the environment is added to this terminal, so it instantly works, and it's always using the correct Python Python interpreter. Okay, so can I go to terminal here? So rework 2025, perfect, classic, experimental, deprecated. So show project settings. And here we want probably something like that, right? So I don't even know anymore where this Zig thing went. Tool chains, it's in local share Zig. Okay. So we basically got, give me a new one. Also make this big talk. There you go. So it's in local share Zig. And then we got this one. Okay. There is still a binary. Okay, and if we go back to terminal, give me the thing like that. So can I say, oh wait 1 second, if I click here, copy, paste. Okay. So do I have to do like that, or can I just write, yeah, add something new and then the original path after it? I don't know. So we'll go here. I think yeah, that was wrong. So we need that again. Copy. Then we simply put that here. So Zig, and then we put a colon there, and that should be good. Okay. Apply. Then let's close this down, and it was like this. There you go. Unknown error. Version not what? Okay, so I just have to say without minus minus version. Perfect. Okay, and then we wanted to add a raylib to our dependencies. So where is this here? Raylib. And I can say zig fetch devil. I don't know. Let's do that. And okay, let's see if that works. So resolved ref devil to commit whatever. Okay, it did something, and then it basically puts that in the dependencies. So it has a URL. And it also has a hash wherever this is coming from. Okay, so we got that. So what's the difference between root and main? By convention, rootzig is the root source file when making a package. Okay. This is a documentation comment to explain the print another message function below. So I think this one is like file level documentation. Then we have an import that we name like standard. And we have a sub package, I think, that we name IO. Okay. Okay, and then we have test basic functionality. So we have tests and functions in the same file. Yeah, it should be big enough, is it? I don't know. 200. Come on, let's go for 200. It's the root source file when making a package. Okay, so and I think main has a main function in it. Okay, I see. Where is this coming from? Prints a standard error. Order S belong to us, code base. Simple test, fuzzy test, test one. Okay, so this will be quite some syntax to digest. Standard out buffer. So I guess this is an array of type unsigned 8-bit. And it's initialized with nothing. So here we got standard out file writer is, okay, so this is actually quite nice here, right? So when I look at this, I see basically Kotlin. Yeah, so in Kotlin, it would be almost exactly the same. So it would be var something and the type, something's type is, so, and I think the difference is, and that's what I already know, is that const is in Kotlin just val. So we have values that are constant and cannot be changed. And we have variables that can be changed. And I think in Zig, this is just var and const. Okay, so this is, I don't know. So this is dot init. Is it an access? Is that an access to a method inside writer? Inside writer, not writer. Init, no, it's a public function. It seems like a high-level function. But does that mean it returns a writer like this? So this is, okay, so maybe, okay, so how does it look? So this is writer. So we have const writer, which is this. Is this a module? Something like a Python module? Okay, so then we have a, I don't know, an import built-in. I guess that's built-in functions, like OS tag. So this checks if it's Windows. So what we got here? Okay, so folding seems to work. So let's see if I have a longer function like this. Yeah, I can fold it together. So if we allow ourselves a quick return to the Zig plugin, there should be something like how was the extension point called, or was there no extension point? So let's see, in core, resources, and here we have the XML. So brace matcher, self-managing commenter, Zig parser, quote handler, syntax highlighter, factory. We have an enter delegate, enter handler delegate. Spell checker. So this is Zig, obviously, and that's Zon. So Zig line indent provider. So it's weird that this is marked as red, because so core depends on language. Okay. Video outline, no, that's not it. Folding builder, there it is. So where is that? It's in, okay, in LSP. So the folding support comes from the Zig language server, actually. LSP4j features folding range. Here I'm looking at that. Folding range builder. Okay, perfect. So Red Hat DevTools, LSP4j features folding range. So do we have code for that? And if yes, obviously we got code for that. Red Hat DevTools. So this is implemented by Red Hat. Okay, perfect. Okay, good. So let's return to C line. Okay, so this is basically um, how this is done. Then we have, so what is all that here? There are commas here. Why are there top level commas? So IO file. So we have imports here. I understand that, but what does that mean? Why is there a comma? Tracks the true seek position in a file. Okay. Getting started. Learn. Language reference. I don't know. Standard library documentation. No, let's go to language reference. So commons, doc commons, namespace, identifiers. So here it's top level declarations are order dependent. Okay, I see that. Still, there's always a semicolon and not a comma. Is that something from a library or not? I don't know. String literals, zig test, variables, namespace level variables. No. Test namespace level variables. So locally scoped. Yeah, I see that. Okay. So what I would do here, if I doesn't find it immediately, is we can just mark that or select that, select it bigger, and then see what. So then it selects the whole file. Crazy. Okay. Okay. Can live with that. So I should have turned on internal mode. Oh, of course I don't. Why is that? Okay. Let's see. Diagnostic tools show. No. Where is it? Custom properties. So, oh god, that was idea.internal mode. True. I don't know. I don't know anymore. There you go. Idea is internal. Okay. Idea is internal is true. Okay, so property files. Okay, no, dismiss. We don't need it here. Okay, so we need to save, and I think we need to restart C line. There you go. Ah, wrong project. It's already open. Oh, I wanted that one. So, okay, JetBrains AI Assistant version is not compatible. I don't know what to do about that. Require IDE build whatever or later. Just update everything. Okay, while we do that, I will grab something to drink. Where's OBS? Here you go. You can look on the workbench. Okay, maybe we can quickly assemble a thing there. And then we're going to show you um, how it inspected. Okay, so let me quickly jump over there. I already got three. That's the third one of these. So it's some kind of holder for electronics equipment for my brother. And that's basically, that gets clamped down somewhere. Here, can you see it? No, you can't, obviously. Okay, let me do it like that. So you can clamp that basically here, down here, and then both sides. And then you have a holder for electronics equipment, a specific one that I think he needs for the job. So when I printed that basically in three big parts, so you have the big clamps here, and these big clamps have small holes that go in this direction, and then we have these pins here, and then I use simply a very strong glue. I don't know the English word, fast glue, or I don't know, speed glue. It it dries up within seconds, and it's really strong. So it really shouldn't. So before this comes apart, I think the whole thing breaks. All right. So okay. So these things just go here. Like that. This goes here. Like that. And we're done. We got 1, 2, 3. Let's see. Okay. And a third one, and a fourth one is already in the printer and doing its thing. Okay, so we were here. So now we turned on internal mode, and that should help us, hopefully, to understand that here. Because what we can do is tools, view PSI structure of the current file. There you go. And this is basically the IDE's internal representation of the code. You see it's, let's do it like that. Make it bigger here. Or maybe just, can I increase size? Yeah. So it's very similar to an AST, to an abstract syntax tree of the code. And I can go here, I think, let me see. Like this, like this, like this. Okay, so this is that. So Zig container declaration implementation. So, but that's not it. Field implementation. So that's a declaration and that's a field. Oh, so what? Really? So has an identifier, and then there's a type expression. See here? Okay, so what does that say? So zig container field. Okay, how does that? Okay, so you can just put it there and basically. Okay, so my understanding is that we have these. That's a document. Okay, comma, and then there's another declaration implementation. So that's another declaration. Container declaration. So the zig file. And here it says container members. And is that the whole file? That's the whole file. Okay, so you. Okay, so what that means is, if I understand it correctly, that you should be able to write, and now we closed it down. So in our code here, where was it? Writer main. So we have here, this is of type IO file writer. Okay, writer. And then I should be able to say standard out, out file writer dot IO. Okay, no documentation found. And then probably this thing, so you can have, I don't know how this is called. Obviously, it's not a module. It's something else, right? So you can have variables in the container, global ones that you can access. Okay. Okay, so I think we should just start because I don't have a clue anyway, so we can just start. So what we could do here is we could just run that. So it doesn't say anything else than what it prints here. Standard log info, accessing command line arguments. Okay. So this is run with zig build run, and I think building is optional when I have already built it. Zig run, no, zig build run. Okay, so zig build run, and if I give a command line error to list available steps in zig build run, okay, info arc. All right, and so and if I see that correctly, right, it just builds an executable. Random gradient effect. Okay, so is that already the thing? So let's go there, zig out, and binary. Perfect, and now I can say, okay, so where is this coming from? That's not, right, that's not coming from zig build. That's somewhere here, is it? No, it's not. Where is it coming from? info arc, try to slice allocator, all your code belongs to us. So that's info. In order to do IO operation, need an IO instance. std out is for actual output of the application. For example, if you're implementing gzip, then only the compressed bytes should be sent to standard out, not any debugging messages. Okay, that was coming from us. Don't forget to flush. Okay, so that's it. So where is this coming from? Where is this string coming from? Because I did not call zig build run. I simply called the oh, here it is. Try random gradient effect, print another message. Cannot find declaration. Import. Okay, so maybe import random gradient effect. Okay, so right, so when I do import, then it uses the root zig. So okay, so but why? So it knows that. Does it know that? No. No. And it doesn't know that then. And that's a shame, right? Why are there no references here from this thing? So const, and I say simply, and it doesn't know that it's called random gradient effect. Why exactly? Maybe rather here. It knows it from here. Okay. Okay, so what I thought we try to do is rather simple. Potentially it's better to do it in a new window so that we see exactly. So what I wanted to do is I wanted to see wait, here we go, here we go. Okay, so what I wanted to do is the following. we start with a random image, right? I will just type it out again. So we simply say we create a random real between 0 and 1. So like this, okay? But we're not going to create only one. We say, okay, make it, I don't know, a matrix of 5 by 5, and we can do it bigger, and then we can just wrap, and I'll write it out here so you see we wrap image around it and we get a random image with noise. Okay, and then the thing is, the nice thing that happens if you have a gradient filter. So if you do gradient filter of that thing, the last, that means last thing, okay? Let's say size 5, then it looks like that, and you can't see anything because the gradients are too small. I mean, so, but we can just do image adjust to normalize the pixel values, and then we get something like this, okay? So that's the only thing we're doing, okay? So, and I would just put this down, the image adjust here. And for the sake of brevity, I put image here, and I just reassign the filtered output again to image, right? So we start with a random image, and then we do that like this. And the thing is, if we do it again, you see that these things start to kind of move, right? Like waves. And it only works because we're always rescaling the whole image, right? So because the gradients here in that image will be potentially smaller here, right, than if you have a black-white edge here. Although with the kernel size of 5, maybe this averages out, right? But the image adjust is the important thing. Okay, so, and we can just do that over and over again, right? And then it looks like this. And I thought that's pretty easy and pretty nice looking. So now it's pretty fast, right? So we can decrease the speed a bit, or we could just put a delay there. But what we can also do is, okay, so we calculate the gradient filter and the image adjust, and we assign it to image, and then what we output, basically the final expression, will be a colorized version of it. So what if I click that here? Ooh. So, and let's use something nice, something maybe the deep sea colors look pretty good, or the sunset colors are always nice. Something that ends in black, right? So that the black stays black and not some other thing. So sunset colors was good. Maybe temperature map. So let's try the sunset colors first. So we colorize image and right. I need to give color function. And then we say color function goes to sunset colors. There you go. Okay. And now it's really, really slow. But you see that it's only slow because the frames are need so long to be rendered, right? So, but what happens is that the frames still skip quite a bit. So the question is, can we make that slower, right? So can we not make that the frame by frame skip is so big, but it's rather slow? Because I think when we do it something like that and we compile it down, it will be much, much faster, especially if we use something like Raylib with OpenGL, which is already quite quite fast. And yeah, which is already quite fast. So it would either be too fast, right? But I don't want to put a delay in there, at least not a delay too long. So my goal is to have something like 30 or 60 frames, right? And colorizing this thing and calculating the gradient filter stuff shouldn't be too complex. So it will be much faster in Zig that is compiled down than it's here in Mathematica. So that being said, I thought what's probably a better way of doing it is not assigning the whole thing to the new image, but just a portion. So basically like a linear interpolation, right? So you have the first state, so state 1, which is the one where you came. Then you have the new state, which is state 2. And you want to say, okay, so the new state is not, so what, let's keep it with image. So we have image, and then we have some filter image. So right, that applies completely. But what we could take here on the right side is the original image and just add them together. And now we say, for instance, okay, use a very high a scaling of the original image and a very low scaling of the newly calculated filtered image. And essentially it wouldn't even make a difference if we do it like this, right? Because at the moment we wrap image adjust around it, it will be scaled down to 0 to 1. So why not, let's try that. So the image adjust is good here, and I assume that if we do like that, the influence of the gradient filter will be very, very small. But let's see. Okay, so, and then let's also see that we always start with a new random image like this. So, and you see now how it forms, right? And now the frames are still slow, right? But the movement is much smoother. Doesn't look too shabby, right? I want to hear my TTS again. I didn't know that Restream had something like that. Let me bravely comment on my own channel. No, I don't want it. Ah, it looks on stream, it looks really nice. Come on. Ooh, this looks really nice.
Halleruten. Ah, this looks really nice.
Oh, it's not ah, it's ooh. How can I say ooh? Okay, so let's use the other one. Ah, this looks really nice.
Halleruten. Or, this looks really nice.
Ah, it's so bad. Okay. Now, I heard someone talking. Okay, and you see basically it gets smoother and smoother. So, what we should test first is if it has the desired effect, right? So, in the end, I probably want, maybe I don't want the waves. I don't know, right? So, but we will basically skip the colorization path first. Let's kick that out and run it again so that it's faster. I think we can live with that, can we? So what happens if we increase the filtered version? Okay. It seems to converge always. Maybe not. Let's see. Yeah, it seems to converge to exactly that thing at some point. That's crazy, right? Hmm. Okay, and let's make another test. So let's use this here and say, okay, we go for that. We only show the gradient, right? It looks like this. But now we will increase the filter size to, let's say 15. Ah, it's even faster. Okay, so that will not help us because the single frames will have long steps. So let's say we don't make 5, so let's go for 2. The waves become slower, but they also become very hard, and I don't know the word, right? Why is my thing not showing? Okay. So maybe we don't want that. So what else can we have? So we could do another thing. So let's say we want to use 10, which is quite big, okay? And then we first test out. I think with something like that, it will be quite impressive. It looks good. It looks good even in black and white. Okay, so what happens if we multiply the two images? Oh yeah, so I forgot to say. So yes, these are images, but basically all the basic operations like adding, multiplying, scaling, whatever are implemented by just doing it on the pixel raster that's contained inside the image. So what if we, okay, so that was not what we wanted. What if we do like this and then say here, I mean, understand that it's going to be very dark. No. And another image adjust. Nah, well, everything happens here in the corner. Okay, so multiplying doesn't seem to do any good. So adding is the way to go, I think. Dividing is a bad idea. There will be potentially things that are close to zero. And if it's not falling apart, it will definitely scale some pixels up that much that an image adjust at the end will destroy it probably. Okay, so an addition it is. We do it inside. So something like that. And what if we go crazy with the size of the filter, like 30? I see it doesn't. The filter is so big, right? It can't really get rid of the underlying high frequency noise. Maybe over time. I don't know. But it doesn't look too... Does it? I don't know. But it looks really wavy, does it? Okay, so what if we initialize the image differently? So what we could do is we could say, okay, image is only, let's say okay, I'm blanking out. So image is an image and it's random real, 0 to 1, but it's only, let's say 10 by 10, and then we say scale image, rescale, image resize to 200 and like this. Okay, so then we have a big one, and let's make it even smaller in the beginning and use a different interpolation filter so that we get very smooth resizing. How can we do that here? Where is it? Resampling, automatic, resampling, and we want something like, I don't know, cubic. So does it work if I say here resampling cubic? Yeah. So now we start off with that, and a very big gradient filter should hopefully create a very wavy thing. So let's use that as initialization. Oh, wait. No. I want to have you first. I don't need that. Because the other idea I had, right, which is one step further, so we can just visualize this image here, and that's okay. So the other idea I had was, and the reason I had, okay, so the other ideas I had is just make a 3D plot of this, just view it as a height field, right? Black is very low, white is very, very high, and then we just make a smooth plot because we had an example. I'm not sure I find it now, but it looked really nice. Let me see. Let me, you need to endure my face for just a second, and then I probably can dig it out. Here you go. Okay. And then we want okay, so wait. So we got that. Where is my browser? What? Nah, okay. I need another second for some reason. Okay. I think I can show that. So let me close down here and then you can, there. So we got this visualization. It's really, really simple because it's one of the, I think it's one of the easiest ways to plot a 3D function, right? If you have a function that results in height, so if you have a function like f on x and y, and this goes to a z, right? So one height, then this is the easiest way because you just iterate over the columns basically if you need that, right? Or you do your own grid and then you just draw lines. And if you draw lines, you will see that you have these overlapping things like you have on the high points of the wave here, right? Where you see several lines that should be behind it. But you can also start drawing from back to front. And then basically not drawing just a line, but a line with the bottom filled. And then it looks really solid. And this is awesome, right? And this is not too complicated. It can be done easily. Okay, so, and I thought maybe something like that would work here too, but this is probably, okay, let's see how that would look, okay? So, we got our image, okay? So I think it was called image data. Yeah, so this is the data field, the pixel values, if you will, and we could do something like, is it list plot 3D? Let's just feed it in. Ooh. So it looks like that, but it took quite a bit of time to render. So let's, how can we, that's almost a second to render. So we need to decrease here the quality. Wait. So how do we do that? Annotation, tooltips, style, no, 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 no. So let's say, what if I do plot points? Oh, it doesn't exist here. Region, plot style. Data range, color range, clipping style. No, no, no. Boundary. What does it say for method? Plot label, legends, range, region, style. This again, plot style. Preserve image options. Oh, what else? Vertex colors, vertex normals, viewpoint. No, no, no. I don't know. I know. Wait, I know. So boundary, clipping style, color function. No, we want to have only the mesh. Let's see if that's faster. Mesh style, mesh shading. No, that was just the mesh function. No. Mesh shading, color function dark rainbow. Mesh shading is, okay, so what if I say mesh shading is none? Oh, it still takes 8. Ah, wait. So that doesn't make sense. Data. Mesh 10. Mesh function is okay. I just don't want mesh shading. What if I say color function none? It doesn't even, what? Like this, but the problem is it's still, I thought there's some quality stuff. So must be rectangular array. Okay. So there will be holes. Yeah. The following wrappers. No, we don't have wrappers around the data. Call out label placed. Okay, we don't care. Access boundary style, box ratios, clipping style. No, color function. Color function scaling, data range, filling style, filling under the surface. No. Although, where did it lead me? Oh, here, filling. No, that's not what I wanted. Max plot points. Here we go. So let's see. Max plot points. I don't know, 5. What does 5 do? Okay, so 5 is really 5 across. So basically it needs 256, right? So let's make it, I don't know, 64. No, not 64. 64. Oh, it's still slow as hell. Why does it take so long? Max plot points. Hmm. Let's see. So we say automatic, and here always from 0 to 1. Okay, let's just try that. Let's see what happens. So we do that, and we don't have data here. We say image data image. Okay. I mean, it's not too bad. And it would be totally random, right? So there would be no structure in it. Okay, so we put that on the back burner. Okay, so we got an idea. Um, and the idea is that we have two things. Either we make some moving stuff, or we have something like that. And we were about to say, okay, so when the filter of the gradient is too high, then weird stuff happens. So we get ripples and we get very big movements that look wavy, but also very small areas here. Okay, so let's, what if we even increase it further? I mean, probably the effect is too big. So let's reduce it to 20. I think for an image, something like that could work, right? And it's probably still too big because it looks like big waves going out from the center. So we had, what did we have? We had 15. Where did we see the nice spirals in the end? Was it with 15 or was it with 10 or 5? I don't know anymore. What happens if we say, okay, 0.5, we decrease that? It seems to keep doing it random. Okay, so what did we have above here? So we had that. No, it wasn't that. It was this here. We had 2 times gradient. And was that the one? That was the one that is really ending up in a spiral. So this looks more like, I don't know, like cells a bit. And now it looks like a flower. So I think this is perfect, right? I'm not sure if we can really reproduce that. But let's keep in mind, okay, so we want the image adjust of the original image and 2 times the gradient filter with a kernel size of 5. Okay, because the next thing is to think about, okay, how do we implement the gradient filter? So we could do a gradient kernel, right, and do and fold it over the image, its image convolution. But I was thinking, and that should work, right? So if we look onto the gradient filter here, so it has this nice thing. Okay, it says, okay, it takes the image, it makes a convolution basically in the two orthogonal directions, right? So you have basically a dx and the dy image, and then you just combine it with with the expression below here, right? You square every single image um, to make it positive, and then you add these squares together and take the root of it. Okay, so and then I thought, okay, so doing this can also be done with a convolution, right? We would need a pretty big convolution kernel that we either need to calculate or whatever. And then I remembered I did a long time ago, I did something with recursive Gaussian filtering, and the nice thing is that you basically only need a recursive filter that goes through one line of the image. So it's a 1D filter. You don't need any convolution. It's just a recursive scheme. So you filter one line, and then you filter basically all lines in one direction, all lines in the other direction with the same filter, 1D, and then you do the expression where you add everything up and take the square root, right? So, okay, and to test this hypothesis, I think what I did is the following. Yeah, so no, this one. So what I did is basically we take a Gaussian, and here I simply use the PDF of a normal distribution and a 2D normal distribution, and I think this is called was it like that? So I think we want a multi-normal distribution. So zero and let's say I don't even have, let's say 1. Can I do that? And then wait, what does it want? Multi-normal distribution. Ah, yeah, okay. So in the PDF, we want an X and Y. This will go crazy. No, it won't. So X is something weird. So we get something like that. Okay, and basically it's just a in two ways. Okay, so you're right, and that's not what I okay, so yeah, and that's not what I did. And what I did is basically say, okay, so we have something like that. So x above minus x squared, to make it clearer, put that into parentheses plus y squared. So like this, and then let's say from x of minus 2 to 2 and y from minus 2 to 2. And we need to plot 3D. So, and then we get this beauty thing, right? Okay, so, and what we want to do is take this and just calculate the partial derivative in one direction and then the other direction. And that's basically what I did here, right? So I'd use exactly that expression, and I calculate the derivative in x direction and y direction. So, and if we take this, the x expression, we get exactly the thing that we saw on the documentation, right? It's scaled differently, but we don't care about scaling. We don't care about anything because we're not trying to make science here. We just want to have a nice image effect. So, and then we got this and that. And okay, and the next thing I did, okay, I used this expression, so this one, which is the X version, and I just created a convolution matrix of it. So something like table, and then we go from y, I don't know, minus 2 to 2, and x is minus 2 to 2, and that's a bit small, right? So there's nothing in it, and let's put floating point numbers there, and then we can say, okay, just make it bigger, right? So here I use something like the whole range divided by 15, and the whole range divided by 15, and it's a big matrix. And when we look at the dimensions, we get 16 by 16, and it's probably not the best thing because 16 is an even number, and probably we want, I don't know, do we want to have a center pixel? Let's say we want a center pixel. Then let's divide it by 14. And then we are 15 times 15, okay? So, and that's basically what I did here. So, and then we have the two matrices. And we can look on them and say something like list plot 3D mx, and then you see it's the same thing. Okay, good. So, and then we can test out basically if the same thing we tried above here works if we implement this gradient filter ourselves. So, and that's basically, let's say we call it filter, we get an image. Yeah, an image, and what it should do is the following. So we want to calculate image convolve of image with mx, okay? We want to square that, and we want to say image convolve of image with my, and we want to square that as well. And then we want to say square root of everything. And that should be fine. So this thing, and if we now say filter, we get something like that. The reason it looks so weird is because, as I said, we did not care about normalization, so it's far too bright. Let's fix that right here. I'll just say image adjust, and then it looks like this. So, and now we can check if this is indeed the thing that we do here, or if something is really, really off, okay? So we take that here, copy it down. Instead of gradient filter, we just say filter our image. We don't need another argument. Okay. So the thing is, we use a very small kernel here, right? So we used 5. We didn't use 5. We didn't use anything at all, right? So we just sampled this this derivative, but it seems to work, and it's probably too small. So when we have 15, we need at least 30, do we? Okay, so let's calculate these things again and say steps. Let's say 4 divided by not 15, but 29. And then we say here steps. It's not steps, it's yeah, come on, step size or something. Yeah, let's make it step size. Step size. Step size. We do that here, and we do it here, and here, and here. Okay, and then let's check. So this is 30 times 30, and now let's try again. So this is our thing with the filter. I didn't use Mathematica for so long. So what does filter say? It uses the global mx and my image convolve. Okay, so let's say not 30 but 60, just for shits and giggles. Let's say 59. Okay, and okay, yeah, it's getting closer, right? Okay, so I'm not sure anymore about this parameter here. Okay, so something like that will work. We may have to play around a bit. Okay, so but I don't want to have the I don't want to implement this big convolution with these big matrices. I'm not sure how much math we can do in Zig. So what we're going to do is we will implement that in a different way, in a recursive way, where we just have to filter. And so that's the first thing. So I have the implementation already in Python. So now we will just try to hack it down in Zig, I guess. I don't know. So let me dig out the Python version. So I think I got it here. Yeah. So it's here. I will just keep it on the other screen so that we can look together here. So I don't know. So what? Okay. So first we need to find out a zig file. So let's say I have a filter.zig here. Okay. So completely new file. And I think it was public function, right? Okay. We need a function that calculates a normalization factor. Normalization factor. Okay, so I guess we need a type here. So the output type is a float or a double. So that's good because I have no clue. So I'd say we use 32 bits. Okay, so and then it gets definitely it will get a arguments, but just to make me understand if that works. So something like this. Okay. Good. And if I go now to my main zig, I can say const filter is do I need to import it? I don't know. Import filter. Oh, it's an add. Oh, there's an add. What does import do? Imports the file at target. Okay, so strings are basically arrays of unsigned 8 bits. Okay, good. Imports the file target, adding it to the compilation if it's not already added. Target is either a relative path to another file from the file containing the import call, or it's the name of a module. Okay, so they're all modules. With the import referring to the root source file of that module. The root source file is probably that thing. And I think this all is then a module, right? Okay. Either way, the file path must end in either zig for a zig source file, okay, or zon for a zon data file. Either way, the file path must end. So here it doesn't have, right, the standard library. So I guess when I refer to something, a package, or how they call it, a module, then it's just put the name there. We want probably filter.zig. Do we? Type. Okay. And then I can go here and say standard debug print. Return value is s, and it's not a string, right? So how do I say it? How do I say it's not a string? It's a float. And here I don't say code base, but I want to say filter dot normalization factor. Okay. So this is not a string, this is a float. So we need to find out how you print something in zig. So does it tell me here? It's a low-level debugging primitive that bypasses the I/O interface, writing directly to standard error using the most basic syscall available. This function does not switch threads, switch stacks, or suspend. Okay. Higher level I/O log. So okay, I still don't know. Okay, let's just run it. Let's see what error it throws. It's finished. It says the following marker exited. Ready migrated. Okay. Invalid format string S for type F32. Yes, I know that. But how do I fix it? Type of. I mean, do I just put here F32? No, I don't. Invalid format string F32 for F32. Okay. So we need a browser. So how are we going to do that? Can I search here like this only? Print. Okay. Okay. What does it do here? So okay, so it's empty. It always needs this parameter or this argument. Okay. 1 plus 1. Ooh. What? 7 diff 3. So it just leaves it empty. It just leaves it empty. So type of is number of error, a number or error. And it just uses, so what's that? What does it mean if there's an exclamation mark in the braces? Oh, here we go. Primitive type, C, description, okay. Primitive types, okay, yeah, but those are not the format thingies, are they? There you go. Okay, so string literals and Unicode, okay. U, okay. Unicode, new line. Okay, so we need to work that out. For the moment, we can just say, yeah, leave it empty. And I think it should work. There you go. Return value is 1. Although I would have preferred a 1.0 because it's a float. D, maybe? No, it's an int here, undefined. It's also min-max, also integers. Oh, come on, how do I format? Print in zig. Here's a string. Putting all this together, let's see how print works in zig. Okay. Maybe can I just jump to the declaration? Oh, I can. That's good. So buffer, file writer interface print. Okay, so what does that do? Ooh, that's better. All right, so that's basically unfortunate because we use standard debug print, which gives us that here, which is not helpful in that case. So if we jump here, it uses standard error file writer interface and then print. And here we get the whole deal, everything. So X and X, numeric values in hex, no. S for pointers to many and C pointers of in U8, print as C string using 0 termination, okay. T, no. Okay, so E is floating point value in scientific notation. Okay, so we don't want that. We want numeric value in decimal notation. So a D. Is that right? No, we were in main. So we want a D. No, we don't want a D. Why don't we want a D? What is if I say an E? Okay, so that looks okay. What if this thing returns something like that? What happens then? So, okay, so this is correct. So you see it here, right? And what if I use D now? Okay, so then it gives me the decimal point. Okay. And can I... So if we go here and here. Okay, so optional value as either the unwrapped value, no. Arrow union, no. Address delegates the format method of the type. Passing writer and expecting, okay. Okay, it's good for now. So, okay, we don't know if that's the right way, but we can use that. So, let me here take a peek. So, what this function gets is, okay, it gets a, so if I remember right, so sigma, which is f32, is that correct? Can I do it like that? So do I need to say something? Okay, maybe we need to check the documentation really. Do I need to say that it's const or something? Probably not, right? So n1 and the type is always necessary, right? N2 f32 n3 is also f32, and what else? So the same for D1 f32 and then D2 D3 and another D4 and signed is bool. Okay. So this is D1, D2, D3, and D4. Okay, so it shows me arrows. Ah, yeah, because I did not use them. Perfect. So the first thing, I need to copy code at some point because I don't want to write down all the formulas here. I can share the paper where this is coming from. So we say, okay, I think now I want a const omega, and I think it can derive the type, can it? Comp time float divided by sigma. Perfect. So, okay, then we need, okay, now it gets complicated because this is complex. I don't know. We need complex numbers. So find complex, please. Please, 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 let there be no, 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 no. No, no, no. So I think one of, so if I go back here, standard library documentation, right? That's the right one because there should be a math library. So namespaces, types, values. So here we have math, complex, that looks good. A complex number consisting of a real and imaginary part. Perfect. So we have add div. Okay, that should be hopefully okay. Let's see. Let's see if that. Oh God. I think I didn't consider that. How do I use it? So it's in math, right? So how do I use it now? Is there some? So I guess I need to say something like const. I don't know. Complex is, or maybe first math. Import standard math. Ew. Wasn't there standard? Standard? Is it standard math? Okay, let's do the following. Let's go here and say, okay, yes, we want standard. Okay, like this. That should be, and that's not math, that's standard. And then I want to say const math is standard.math. Okay, here we go. Like this. Okay, and then we say const complex is standard.math.complex. That's a type, right? So they always have to do that at, okay, so I mean it makes sense to do that at the top of the file. But I'm wondering if there's an easier way. Okay, so the thing is now I'm sorry. The thing is now that we need math.exp any type. Okay, though that's good. What's exp1? Base E exponential function on a floating point number uses a dedicated hardware instruction when available. Exp2, base 2, no. Not, okay, so the question is, does it know what to do with the following, which is complex. Okay, I don't know. Let's check. So we got math somewhere here. We have complex, and probably it's not here. Maybe it's here. Values. No. So there's no imaginary thing. Is there? So I do have to say I do have to say here, that's basically complex with this as real and this as a imaginary part. Uh, uh, okay, so it doesn't know it. Um, so this is complex. Okay, so I should have looked here. So we have complex. A complex number consisting of a real and imaginary part. T must be a floating point value. Create a new complex number from the given real and imaginary parts. Okay, 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 okay. Returns the product of a complex number and I. Okay, so that's what we want. But, so, okay. Okay, so I guess that is wrong here. Complex dot. So I think I need. Pooh, okay, so how do also we have complex, which is just the package thing, right? Okay, so I think I saw that before. So what if I write here const? This is complex dot complex, and that's not a type, is it? Oh, I'm so confused because I is a type. And then I say, I don't know, dot init, and it gets that. And this, was that how it's done somewhere here? There. Okay, so it's not, okay, it's not curly, it's normal. And then, so IO file writer. Standard IO. We have standard math. Let's do this is, okay, so this is standard math. Standard math complex. So the type is also available here, is it? And the type here is like this. So, and then I can say init, but I need real parentheses here. So, and then I can say omega mult by by I. because that's what we're going to do. And then we say const z. Okay, so we write it first down. Math dot complex. Again, F32. I'm not sure. It doesn't need it probably because it can use inference to get this. But let's say, does it take? Oh no, it doesn't. So like this, and here I want to have. Okay, so the standard, we need to kick the standard. Okay, I can write math, that's okay. But that math.exp oh god, we will need a debugger, but we don't care, we can do that. So we got this. So now we got Z. Now we try it without initializing it. Is Z dot, is there a reciprocal? There you go. Okay, let's put also a comment here. So this is the forward. That's basically the forward direction. And then we also have the backward direction. And we just need to calculate these values to scale the filter properly. And we're not even at the real filter, by the way. Okay, now let me copy the line of Python code here and put it here. This is Python. And we need to do that. Okay, so const dp. I'm pretty sure that's not that's an error if I do it with a capital D. Not sure. So dp is okay. I'm very sure I can't do something like that. Plus D1. Yeah. And now it will kick me. It doesn't. Nah. Can it? But it doesn't know the type. So that is already weird. So, and here I can, let's say, just return dp dot. No, it doesn't know it. It does not know it. So okay, so okay, and can I? Okay, I'm not sure. So let's first compile it and see if it. So this will okay. Let's first compile this. That should be. Oh no, it's not good because I don't use the variables, and I will. Okay. Quick restroom break, and then I'm back. You can look at the workbench. Two. Okay, so I mean, we had so we get so used to operator overloading, right? That you can just add two complex numbers or add a normal real with a complex number and it does the right thing. So now it becomes a bit tricky, and I don't want to use any help except in this case. Let me just quickly check if I'm not doing something completely stupid, okay? So let me ask Jolly if I'm right that I have to call basically the complex functions one after another because there's no operator overloading and no basically addition or things for complex number or for mix of types. Okay. Let's assume the following Python expression. Here, ZP is a complex number, but while all others on the right hand side are floats. Exactly so. What is the preferred way to write this line in Zig? Question mark. Okay. So I'm not completely. Okay. So okay. So that's something I haven't I haven't considered. Okay, so let's switch back. We can continue. There you go. So okay, so this is what Charlie suggested. Do it like that. And now we also make a new type, C, and we say complex and F32. In that case, I didn't know that we just use 32 bits. And now okay, so and now I should be able to write this here. Okay, so I can skip it because we have the inlays, right, where it shows if the IDE and I think it's the language server in the background knows the type. So we leave it out here. We say C init. Okay, so it knows that. Then we can leave that out as well. And we can say, I'm okay with writing math, I guess. Exp. And then we multiply it by, okay, so it didn't know that because I didn't post it. I just posted this formula down here, right? So that we get an, that I'm sure that I didn't overlook something. I can just write it down somehow. So here we have Z reciprocal. Okay. And then we come to this beauty here. Okay. And here it basically tells me to do it like I was afraid I need to do it. So this is basically okay, so okay, so we will start here on the front. No. Okay, so the important thing, okay, I understand. So the important thing is here that we have here times ZP, here times ZP squared. So, and we can rewrite that in Horner form, right? So what we can do is say, so the above here, dp is the same as, so d4 times zp plus d3 times zp, and if we multiply that out, right, we get here a zp squared, and here is one zp on there, right? And then we say, okay, plus d2, we put that all in parentheses, and then we can say times zp, and then we have here 1 zp, here is squared, and here is already to the power of 3, and then we do it the last time and say plus d1 times zp, and then it should be correct, right? We have a square here, zp is multiplied here, and then we just say plus 1. Okay, so that being said, we need something like, we need a complex number in it. It should be d4 with no imaginary part. And then we want to say, I'm not sure if, let's see how good let's make like this, dot multiply by another, right? And we multiply it by ZP. Okay. And then we say dot add d3. Okay, and then we have basically the shape. So we can do that like this. So now we got that in the middle. We multiply ZP, we add by D2, we add by D1. Okay. Then we multiply and then we add, and I hope that works. Z dot, does it work? Can I do the init here? Inside? Is there one? No. Init 1. Okay. So that was, so why doesn't it show it? Oh, that's weird. So the, okay, so this is going to be fun because, okay, so now, can I compile it? No. Okay, yeah, I know. So I can't compile it because I need all the other stuff. So that was that. Now, let's do the other thing. So in Python, we now want that here. And we can do it the same way. So const np is, we start from the back, is c.init, then n3, and then we go here and say dot mult by zp, dot add n2, does that work? No, I think not, right? So I always need the, like this. So, and then thing, multiply by zp, then add n1, and finally multiply by zp again. So here it complains about something. What does it say? Unreachable code. Oh yeah, of course, because okay, so we got that. So next thing. In Python, we want, okay, so first, so this is the forward path. Then we need backward anti-causal. Okay, and okay, so the denominator of the expression, basically this. So okay, so I think we can use the complete thing here, can we? Copy, and then we go here and say const dm is, and then let's insert that. So we start from the back again and say d4 is a real number. So now we multiply only by z times d3. We add the d3, and that should give me on d4 1, 2, 3, 4 z to the power of 4, and in the beginning we add 1 again. Okay, that's good. So now I thought it's much simpler, sorry. I thought it's faster, but of course, I mean, if you would do it in C, it would be equally lengthy. So we got that, and here we have the following Python code. That seems to be the numerator. Okay, and I think we can, although there's a minus there. Okay, but that's no problem. So we can use here this expression. Okay. So, and that is not np, it's nm, and we initialize it. So here we got n3, exactly. So then we multiply by z, and we don't add. We come on, please. No suggestion. Why is there no suggestion? Okay, so here it's somehow the... Did I do something wrong? Because you see that it's slightly red here, right? And it seems it doesn't know that these functions exist. So that's weird. Why is it giving up on me here? Okay, so the thing is, I need to know, okay, it's called sub. Returns the subtraction of two complex numbers from myself. Okay, so then we just do it like that. Sub and 1 times that, and then we zub that. Seems about right, is it? No, it's not, because this must be a minus. I hope that works. Can I do that? Please. Okay, so let's build it. Build and run. I mean, I have too many unused variables that are red. I'm not sure if okay, let's continue. It should be, we should be almost through. So here in Python, we have this one. H-raw. And let's say here that's a C. So, and then we have and we can't rewrite that. Maybe I'm blind right now, but I don't know how to do that without having term 1, which is NP. It's giving up on me completely. That's not good. Divided by dp and const. I think the rest we can do here, right? We can say nm dot divided by dm dot at and then t1. Okay, so we have that, and I think here we can say, so there are in Zig, I think I read that you can use if as an expression, right? So if signed, we do this, and else we do that. Does that work? We'll see in a second. So, okay, here we need that. So let's see if we can just write it down. So that should be sigma. Ah, no, sigma is a real. Is it? Okay, so we need to say c dot init sigma dot 0 dot 0 mul. Now it works again. So it's weird that this section here is out of order. Multiplied by math.exp of still not sure I can do that. I just write it down, and then we see 0 0.5 and this. Okay, we got that. And let's just, for brevity, put it like this. I don't know. And then here we say, and oh, I'm sorry. No. It's not complex. Sorry. So this is all floating point. Real normal numbers. So we don't need that. We need that. Oh no, of course not. We need that times math. And then here we say like this. Okay. And then here we say times. And here we need, I'm not sure if that's possible. hraw diff why isn't there no imaginary number? Okay, like this. And yeah, you can go away. So that's that. And here we need to say real. So, no, sorry. Well, there shouldn't be a... Okay, so we need to look that up, because if I put a semicolon here, I thought it's not the last expression, so I want to return that expression. But probably either the syntax is different or it's not possible. Let's put it just here like this, and then we check the documentation. So now we got sigma. Okay, let me copy it for you. What we want to do here. We do this. So sigma times math dot x of times abs is the magnitude, right? Okay, so now we need to know. We got this here. And we want to say if as an expression assignment. Escape sequences, assignment, undefined destructuring, skip tests, variables, floats, floating point operators, arrays, pointers. There must be conditioning, while, for, if with optionals. Okay. Okay, so there's no... So it's as I said, but I think the problem is I need to have it like this. If signed. And then we put it here. And then we say else like this. Oh, does it need to be on the same line? Ah, no. Wait. That needs to go, and that needs to go. That's it. Okay, and is that how you would format it? Let's put that here and say reformat it. Yeah. Okay. So this is green. How can I only build it? Okay, I can't build it here. I need to say build and run. Or I can go down here and say zig build. Is it possible? Okay, so we got an error, one compilation error. Okay, I see. Yep. So this is not going to work anymore. What we can do is we can just try it out, right? Yes, I think that's a good idea. So, I just called it dx. Okay, and then we say, okay, so first, the name, derivative normalization factor. Okay, and then we say, okay, so sigma we know, let's say 5.0, and I don't know. So the other factors come from the filter itself, so we don't know. So we just say 1, 2, 3. Although, what are we doing? Let's check again. Maybe it's not the best idea to so add and multiply. So let's make it smaller. Let's say 0.1, 0.2, 0.3 for n1 to n3, then 0.4, 0.5, 0.6. So 1, 2, 3, 1, 2, 3, 4, and we need another one, 7. And then we just say false here. Yeah, of course it's not defined. Yeah. So, okay, and that's what should be delivered. Now the big question is, do we get anything close? So, const, I don't know, let's call it scale, is filter dot normalization factor, and then we had, okay, so 5.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 7, and here we said true or false? False. Okay, like this, and then we just put out scale here. So let's run this. Ooh, I think it did not error. Ah, it did. So something's still wrong. Node called inline here. Return struct. Expected vector of floats or float type. Found complex. Okay, back to the documentation. Magnitude. Hmm. So what we want to do is um, what we want to do is we want to calculate. So the arrow comes from here. We want to calculate the exponential of a complex number. So basically we want to calculate the exponential of, give it a second, just so we multiply by I. So something like omega times I. Okay, we want to do that. I mean, these trigonometric stuff is the only way I see right now. Is there anyone here who has an idea how we can do that? Okay, so what if we say, okay, let's do it here. That's not fun. It's so cexp for complex exp, and yeah, I mean, let's just implement that. I don't know. There's probably no other way. So complex x gets a complex number c and returns a c, right? So, and then we say the real part is the imaginary part is I think like this. Oh no, it's giving up on me because I wrote z or not z. Okay, like this, and then we can say return and I hope I can do that, set.init, and in the in the real part, we do math.exp of the real part times math.cosine of the imaginary part, yeah, which is Ri. And in the complex part, we do math.exp again of the real part. We will probably reuse that one times math.sine of the imaginary part, Ri. So, and here we want to introduce a variable which doesn't work. Nope. Okay, so it's good old const, let's call it E, is we don't use the real part anywhere else, do we? No, we don't. So we can say here like that, and we say set real part, and we call that E. And then we can say here E times that and E times that. Okay, looks good. So, and then we need to replace that. And that was here. And here we just say cexp. Can do that, right? So, okay, run it. Error. So wait, I can't add. Didn't it say it? Oh no, it said nothing. So I always need a complex. There's no automatic type conversion happening at all. Okay. So then, can I do this? And I need to do that several times. So let's just do like this and replace. So that was D2. That is D1. Okay. Then we have the same problem here, I'm pretty sure, which is like this. That was N2. N1. So then we have the same here. That was D3. That is D2. That is D1. We have the same here, which is N2. N2. And then N1. So n3, n2, n1, and we subtract, okay. Good. Let's do it again. No. No field or member function named mult because it's called mul. Where was it? Here. Ah, okay, and now I know why it's given up on me. There you go. Here, same mistake. Okay, so now I know why it was giving up on me. Okay, let's try it again. Ooh. So, but the value is not correct, is it? Where is not at all? Okay, so we need to find out what I did wrong here. So we go here and we will let me make that big as well. There you go. So there will be lots of prints. Oh god, omega. And in Python was like that, right? F strings. Okay. So, and I think I can so this is Z. Can I open that in something else? Okay, so this is ZP. So then we have here DP, DP, and then we got here NP, NP, and here we got DM. Now I think I can say something like delete word. Okay. DM. So what if I say D word? Okay. Then, oh god. Oh, I did something wrong. DM. And then we can say, Christ. So we want to do this and then go here and say like that. Delete word and and delete word and and then here we have. Okay, so as soon as I delete the word, I need to yank it again. Okay. Okay, so now we have hraw and hraw, and then we just hope for the best. Okay? Yes, that's what we do. Okay, now something like import lib dot reload dx, and that worked beautifully. Okay, so yeah, of course, probably should save it, write it. I can't write. Yeah, I did mean omega. So it was on the top, right? Here. Omega. Okay. Oh, goodness. So here, omega. Omega. There you go. Okay. So now we got values for all the things, and we can try out the debugger. Let's see. Let's always on top that here. So go here, and then we had, didn't want to go to the terminal. Shift Control 12 like this. Okay. So, and we want to debug that through from here, from there basically. Error running build and run. Debug zig build task requires setting the build step. Okay, shit, it was too fast. But I remember, I think I remember it was, I think in build target. So standard target option allows the person running zig build to choose what target to build for. Here we do not override the defaults, which means any target is allowed and a target is native. Other options for restrictions, blah, 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 blah. Okay, standard optimization options allow the person running zig build to select between debug, release. Okay, so that's probably what we want. Just to know how. So when I say here debug, shouldn't it do it? We got here. So, and that's coming from here. But I and specify the target step and executable path in debug output executable created by build options. Okay, so let's see. what we got here? Build steps is run. Okay, got that. So let's use this here and go to C-line projects, and then we got this one. So, and now I can say, I can't, because I don't have a zig here. Okay. Debug build steps.
Stream elements. Thank you for following Broston45.
Thank you for following. So I guess I need to do something here, right? So, okay, so first let's get it done on the command line. So, here. So I can say zig build, and I probably, okay, so that works. Zig run, but I want to build it with debug symbols. I think that is one thing. So what if I say zig build work now? Okay, so that works. General options. Oh god. Okay, so zig build steps. Okay, so the steps are install, uninstall, run, test. So probably I want prioritize performance, safety, or binary size. So we want debug, de-optimize. What else we got? None. No. Print configuration, debug log, debug package config, verbose. Okay, so probably that one is the de-optimize, right? Okay, so now I want to say build, and then de-optimize is debug. Does that work? Okay. And I think something like that needs to be included in the run config. Maybe I can just create another one. So zig build, zig run, zig test. So build and run. And it's it's probably a run. Oh no, this is build and run. Okay, no, then let's get rid of that and say, okay, we want a new build run configuration. We call that build and debug. Okay. So build steps are, I think there it said run. Extra command line arguments. Debug build steps. Code completion available. No. Debug out. Okay, so I'm a bit lost. what I should do here. So I would suggest that extra command line arguments is probably this. Maybe not. Okay, let's make OK here and say no, still not. Error. Debugging Zig build task requires setting the build step and the path to the compiled output executable in the IntelliJ run configuration. Okay, there's obviously an issue here already, which is when running tests. Maybe we find something on ZigBrains GitHub. There you go. So there is an okay, so it's just it's okay. Codeberg self-hosted Git download previous version. Okay, there's nothing here. Okay, so we got language server integration, changelog, strict, contributors, additional thanks, description, debugging. Here we go. Debugger settings are available in settings, build, execution, deployment, and debugger menu under the Zig section. Okay. Let's check there. Zig section. It should be maybe tool chains. No, but there is no. Okay. So build, execution, deployment. There is no Zig section, is there? RTOS integration run targets. No, there's nothing I see. Okay, so let's check. So there are only 7 issues. The question is, there are 28 issues here. So expand selection does not select struct field. Running with debugger does not properly set specified working directory. So we don't use Microsoft. Debugging fails with ZigBrains when having an infinite loop. Okay. And structure, external libraries, prompt for paste, async. Zig run and Zig test run actions should be able to utilize build Zig dependencies. Okay, so where's this error message coming from? I mean, we can check that. Probably we need to do it once more. So error running build, debugging zig build tasks. We're looking for that. So debugging zig, there you go. So this is the message we're looking. Ah, Christ. I want to go there, and then I want to see where it's used. So zig debug parameters build kt fail. Okay. So if debug build steps is blank, toolchain, debugging requires setting. No, come on, fold that together and show me the, no, that wasn't folding. I wanted that. Show me the message. Can you show me? No, you can't. So it says what? Debugging zig build task requires setting the build step and the path to the executable in the
Stony
IntelliJ
Troopy. iViewers Streamboo. Com.
to the compiled output executable in the IntelliJ run configuration. The problem is I don't know what exactly the build step is. Okay. Let's do the following and invoke a helper that has access to the plugin source code. I'm not sure if I can make that big talk. Yeah, I can. Okay, so
Broston 45. I don't know what's happening here. I am too new in software, haha.
So hello, Prostone. So do you know the SIG language? It's called ZIG. If you know that, then you probably know it as well as I do. So I thought tonight I try to write some code in Zig, and I'm using CLion with the Zig plugin. And right now the code we've written works, but I have to debug it because the numeric output is not what I expected. So, and now I'm just trying to find out how I can debug Zig code. Okay, so I want to debug my Zig project with the Zig brains with CLion and the Zig brains plugin. However, simply pressing debug results in the message, and I think here that one, copy, in this message from can you show me? Oh, here. Copy. From there you go. Okay. It seems to come from and now I'm not sure how exactly I have to configure my run configuration to be able to debug my SIG program. Your task is to research how to debug SIG programs and to understand what is there's so many. I think there are many C's. Necessary. No, that looks stupid. Necessary. You will know. Necessary. I don't know. What is necessary? There's somewhere a double letter in there. To understand what is necessary. In C line. And C line. Probably I can also give it access to my if you need to investigate in my small SIG example, it's located in there. So here we go. Please provide a step-by-step solution. Okay. Yes, you are allowed. Yeah, confirm. So this will take a while, at least 2 minutes, I think. So Broston, is it Broston or Brostone 4-5?
Broston 45. Whatever
fine.
it is fine.
Okay, so the voice said, so the the AI voice said Broston. Okay, so if you're new to software, so what are you looking into right now? You're trying some Python or some, I don't know, some web development, some JavaScript or TypeScript.
Broston 45. Yeah, haha.
Some Python. Okay, so Python is fine. It's really easy, right? I mean, if you want to compare, so ZIG, the thing that we try out is a more low-level language, and you don't need to understand what happens, right? But basically, we wrote without without peeking, without looking, we wrote this code here. This all, right? And in Python, it looks like, wait, I will find it. Oh God, got too many stuff open. Yeah. And in Python, you have to not look at the prints because these are just debug. It's just from here to here, right? So we had to do all the formulas here. We had to convert them to function calls. Yeah, so it was it was a rough ride.
Broston 45. And I really like Java. I manage it with Spring.
Okay. I mean, Java is fine. So if you can, if you like Java, right? So Java is much more complex than Python, I think. And basically, so if you like Java, you could look into Kotlin. It's completely compatible with Java, and it has some nice features, but you don't have to. Java is also very nice, especially, I mean, if you use the newer versions, I think the language syntax is pretty awesome. I like it. So if you look here, basically, so probably I should have used different colors. So this is one IDE, right? So this is C-Line, and it has a plugin for the Zig language. So it does all the I can run stuff. I see code highlighting. I can, for instance, I can move here, right? So I can go here and follow where the function is defined, and so on and so forth, right? Or I can just call the documentation. So the plugin is doing all that, and this plugin is written in Java or in Kotlin. I think this one, this is Kotlin. No, this is Java actually, right? Oh, no, this is Kotlin, but this is Java. So it's mixed. It's complete. You can completely mix it. And maybe we have some nicer looking code. Yeah, it's not really. If you can write Java, you can also do Kotlin pretty easily.
Broston 45. Ooh, that's nice.
Yeah. So is the thing coming to an end finally? So, okay. Root cause, ZigBrains now requires 2 extra fields for Zig build debugging. Debug build steps. Okay, so I read that from the error message. So if either is empty, it throws exactly that error. The auto-generated build and run config currently leaves debug build steps empty. So pressing debug fails until you fill those. Okay, so I want to fill those. I'm just not sure with what. So for a Zig build configuration, debug does this. Runs a Zig build debug steps that I'm still not know. Okay, debug extra command line arguments. Okay. Looks at debug output executable created by the build, verifies that file exists and is executable, launches that file under the debugger. Okay, that's good. So it does not infer the output path anymore. Okay, so that's probably where I need to set up. So your project's build.zig builds an executable named random gradient effect. Okay, I know. Installs it with b install add effect or add effect. Defines a run step that actually runs the program. That means the debug config should build the installed binary, then debug that binary. Use these values. Okay. Then let's use these values. So working directory should be just this one. Okay, so build and debug, edit configuration. Working directory is correct. We don't have build steps is run. Debug build steps is install. Okay. Debug build steps is install. Debug output executable created by the build. Okay, so I think we only need this one here. I don't know. Where are we here? So debug extra command line, debug output executable created by the build. Okay, so I can, oh no, it's going there. Like this. What is, oh no, it's giving all the full. So let's use that here. Debug output program command line arguments, I can leave empty. Okay, okay. Why install, not run? Run already executes the app inside Zig build. Okay. For debug, ZigBrain separately launches the executable after the build step. So for your project, normal run is run and the debug is install. And then okay, so understand. To avoid double running and gives the debugger a real executable path. So we have that. So we have all that. Select your Zig build configuration for this project. Yeah, use gutter action. This is likely auto created. Okay, then we got that. What to expect? So it should run build install, which builds the so the question is, okay, so the question I got is, okay, so we will just try it. Okay, so now, okay, it did something, but it didn't stop. So, and I think, I think it's not building in debug mode, is it? Okay, now the error is gone. However, it doesn't stop at my breakpoint. Do I need to instruct the build process to instruct Zig build to build with debugging information available and without optimization? Question mark. It could be helpful to check that the build includes, yeah, okay, that's exactly the argument we found before. But actually, since the build configuration uses a standard optimization option, that's likely not the main problem. Adding it for sanity, okay, is a good idea. Troubleshooting. Okay, probably not. At least not as the primary fix. Your build Zig uses B standard optimize options, and for Zig build, that normally means the default mode is already debug unless you pass deoptimize. So for your current setup, Zig build install should already produce a debuggable binary. Debug extra command line arguments. Okay, so let's include this first. Wait, maybe I did it wrong. Did I? What did it tell me? Okay, so wait. No, build step is run, but the debug build step is install. Okay, so probably install does build it. Okay, let's click OK here and let me see. So zig out bin. There's only one binary. Okay. And just for good measures, let's put a breakpoint directly into our main. Now we stopped. Okay, that's good. Let's stop it. Go back to our filter stuff and put the breakpoint right here. And now it stops here. Okay, and it doesn't stop. It doesn't stop in the library code. What? Okay. So what if I go here and say step into? Oh, step into doesn't work. What? Hmm. Can I can't step into anything. Yeah, I do. I step there. Okay, so wait. So I can't step into library code, but I did step into what I okay, so where did it stop? So I can't. What's that? Okay, I need to turn off the assistant, presentation assistant. Ah, that's the output buffer. It's filled with A's. Okay, so here, here it jumps in. Okay, so what's the difference? So it jumps into radian. So it also says const random gradient effect import. I'm not sure why. What's the difference between... Okay, so this is a container, I think. And this is not. This is a type. I'm not sure what Okay. Um, okay, so first let's try edit configuration. Let's remove that again. Okay. And then let's now I get the error, but what? Why? Oh, why is it that removed? Okay, so that should be install. Okay. So it still stops. So the problem is I can't step into. Okay. The problem was that I set a breakpoint in a file that I import in my main file. When I set a breakpoint in main, it stops there. It stops there. Can you search the internet? Ah, no, wait. Also, when I debug my main function, I cannot step into function calls. Calls like the one I wrote myself. Investigate if this is a known limitation or if my approach is still wrong. Let's see. Oh, Broston, you're still here? Ah, darn. I wanted to show you what we what we even tried to do. Okay, I need to check around the step into functionality and the source path mapping logic considering reading sections. Okay, didn't find any explicit import. Okay, I need to look into that issue. Let's explore relevant call sites. I mean, so basically I should be able to I don't know, no, maybe not. So um 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 No, that's not what I wanted. Native application. So what's target? Okay, so I need a target, custom build target. No, I don't want to build it. Executable. Go to the project directory, zig out. This one, okay. And it doesn't need program arguments, does it? Okay. And okay, so I can't debug that. Give me. Okay, short answer, your approach is not wrong. An import itself does not need an extra C-line configuration. What I found, ZigBrains does support line breakpoints in Zig files generally. Okay, ZigBrains does support step into and just force it to the debugger backend, okay? I didn't find any ZigBrains issue or code comment saying breakpoints do not work in imported files, okay? I did find a known Zig compiler debug info issue for inline functions. Okay, what that means. This looks like less like your run configuration is still wrong and more like one of these debugger realities. The breakpoint is on a line that does not have a good stoppable location. The function got inlined. Okay, so I get this. But is dense expression heavy code, for example, chained method calls, single line temporary expressions, pure helper calls, okay? Those are exactly the kinds of places where stepping and breakpoints get flaky if the compiler emits weak line mappings or inline calls. Okay, so it's fine. Zig build config is probably fine now. The remaining behavior is likely a Zig debug info inline limitation, not a missing C-line. Okay, so why I think that? ZigBrains has no special case logic blocking import. Okay, breakpoints are registered by source path with no distinction. Okay, step into Zig has known dwarf debugger rough edges around inline code. Put a breakpoint on every on a very simple executable line in Zig dot not. Okay, so I didn't put it there, right? Try a line like these. From main, use force step into if C-line offers it, not plain step into. Keep debug extra command line arguments as de-optimize debug. Okay, so we tried that before. We can try it again, but it didn't work before. Practical conclusion. So we're not so we don't know much more now. So, okay. What Zig build or install options would I need to completely suppress optimization of the code? No inlining, no nothing. No inline at the source level. I'm considering whether no inline fn is a valid keyword modifier. Okay. Okay, zig build install de-optimize debug, or for a plain compile, zig build exe Okay, so I could potentially just use that, right? So for your project, de-optimize is debug is the right knob. Mark functions no inline. Okay, so edit configurations, we get rid of that. We use this. So install debug extra command line arguments is now minus d optimize is debug. So debug output executable created by the build. Debug output program command line arguments. Okay, so we don't have these. These are just the command line arguments that I would give to a thing, right? If I had them. I don't have them. It just runs. Okay, so now I understand. Okay, so we got that. And now I want to say here, so is that possible? No inline. Mark functions with. Optionally force non-inline calls. Okay, so how do I do that? Do I need to? No, that's not right. So, okay. Where is our documentation? No inline. What? No inline. Test. No inline function call. Calls a function the same way that invoking an expression with parentheses does. Never inline. This allows function with inline calls. See also functions. Okay. Inline function. The pub specify allows the function to be visible when importing another file. Can use import and call subtum. Okay. Adding the inline keyword. I want the no inline keyword. A declaration is so keyword function prototype, and the function prototype is keyword function. What is keyword export? Where is it? I don't see it. Function prototype is keyword function. Okay, so this is function. Then the name. So I can't use it together, I think. The problem is, if I can't use it together, can I still import it? What? So what is keyword export? Keyword export. Oh, it's export, not pub. What is pub then? Wait, where is it? Try here, keyword pub. Where does this come into action? So we got keyword export or keyword inline or keyword no inline. Then the function prototype. Okay. Or keyword extern, function prototype, and then or keyword. So this is the only where is it block, right? So where does it say keyword pub? Here, container declaration, a doc comment, then keyword pub, and then the declaration. And then the declaration. Okay, so it needs to be pub, no inline. Okay, now I got it, I think. It needs to be pub, no inline. Okay, finally. Whew, that took a while. Pub, no inline. Okay, and build and debug. So I think these are all pretty good places here, right? I didn't put something here. So no, it does not stop. So okay, so that was another thing, like call never inline. This one, right? At call. calls a function the same way that invoking an expression with parentheses does. Calls a function in the same way that invoking an expression with parentheses does. Call allows more flexibility than normal function call syntax does. The call modifier enum is reproduced here. So the modifier, never inline. Okay, so basically, do I see that right? That I could do the following, like call never call modifier. How do I get this thing? Where is call modifier? In lang. Const never inline is call modifier never inline. Does it work? So I can say here never inline, then call this function, and so like this, but something's wrong. Expected 3 arguments, found 1100. Ooh, what happened here? Okay, so I need to just, so what's the type of that? Arguments is any type. So, but they pack it like this. In a struct, is that a struct? Okay. Let's try that. So here I want to say like this. And then here, right? Okay, so can I run it? I can. It's still wrong, but I can run it. So now, can I debug it? I can. And does it stop? No, it doesn't. Okay. Can I debug it? Yes, I can. I can say here, and then so I have step into, step out. I have force step into. Nice. Now we're at the I don't want to read assembly. So what was force step into? Alt Shift F7. Okay, so if this doesn't work anyway, we can go back to this. Like that. Like this. Okay. So now okay. And now I can Alt Shift. What was it? Alt Shift F7. Nah. Oh, that is weird, right? Does it build it new? Let's get rid of that and say zig install minus d optimize is debug. Does it work? Okay, so let's try it again and say I can't step into it. Okay, let me still check this one here. Oh, that wasn't here. Zig. Okay, so I think we need to know zig build install whatever. Zig build system. A simple executable. So the basics: user provided options, standard configuration options, and so on. Dynamic testing, debugging, running system tools. There's no debugging here. The Zig build system, like most build systems, is based on modeling the project as a direct acyclic graph of steps which are independently and concurrently run. By default, the main step in the graph is the install step, whose purpose is to copy build artifacts into their final resting place. The install step starts with no dependencies, and therefore nothing will happen when zig build run. Starts with no dependencies, therefore nothing will happen. Okay. A project script must add to the set of things to install, which is what install artifacts function called does. Okay, let's quickly check. B executable root module. B.create module. Create module defines, okay, path is main, that's okay. target and optimization levels must be explicitly wired in when defining an executable or library. And you can also hardcode a specific target for executable or library definition if desirable. Run step, run command. The run command depends on the install step. So this is okay. So resolve target query. Okay, so the target is probably only the operating system. Hmm. Fast, safe, small. Disable reference trace allows shared object files to be GNU LD scripts. Hmm. Previously, we used the Boolean flag to indicate building for Windows. However, we can do better. Most projects want to provide the ability to change the target and optimization settings in order to encourage standard naming conventions for these options. ZIG provides a helper function standard, target, options, and standard optimization option. Standard targets option allow the person running ZIG build to choose what target to build for. By default, any target is allowed, and no choice means to target the host system. Okay. Other options for restrictions for restricting supported targets set are other options for restricting supported target set are available. Sets. Or, I don't know. Standard optimization options allow the person running Zig build to select between debug, release safe, and release fast, and release small. By default, none of the release options are considered to be preferable choice by the build script, and the user must make a decision in order to create a release build. Okay. So, okay, so that's basically when we set. So Zig build summary all. Let's try that. Okay, so we have a Zig cache. What's in there? I don't know. Some binary stuff, right? So nothing. Okay. I want to get rid of that. And what's Zig package? Raylib. Okay, so that's probably all the dependencies. So let's remove that. Let's say Zig build minus d optimize is debug, and minus minus summary all, was that right? De-optimize debug, and minus minus summary all. It's not a minus, it's just like this. Compile exe random gradient effect debug native success. Okay. Wait, I need, okay. So let's see. And we need, this is in Zig out, like this. Okay, so can we um, so let's use debug dump. That should work. Okay. So line number, view, and statement. Okay, let's go to filter. So if we look here, so we got, okay, so these cannot hit. I don't know why. So we got 14, 15, obviously. So let's put it here and here. It doesn't make sense, but let's try that. So if I now debug, no, it just exits. Hmm. Hmm. Okay, and let's not use C-line toolchain instead. Okay, does that work? No. Okay, now it tells me I can't debug here. That's good. I can't debug nowhere. So I'm doing something incredibly wrong. And I don't know why. No compiled code for line 29. Target architecture is set to auto, which is currently that one, which is okay, I think. So no compiled code. No compiled code. So it, wait, maybe I don't know. Wait. Do I need to say that the file is somehow needed? Add executable, create module. Path is root source file. Const imports. So, okay, maybe that helps. Hello, Zig. Target and optimize. Okay. So I think let's see the following. Zig signal processing. I think I saw something like that. I just want to see what's in here. So no. Let's say image filter. Signal, that's the one. So, okay, let me see here. How did they do it? So that's only the root version. Add library. Okay. Okay. C. Okay, so run tests. I think these are only the files that contain test code. Okay, so I'm not sure what I'm doing wrong, but okay, so let's skip that for the moment and go the easy route and just add debug print stuff. So standard debug print. Okay, so we need standard. We got it. And then we say here just debug print, and here we say no, not that, we say like this. Okay, so let's just run it. Okay, I can here build and run, and all right, I need okay, then we want the same here. So dp is dp. We got here np and I'm not sure. I'm pretty sure that we are wrong down here already. Still, T1, T1, and let's put that out, and then let's just run it, which is hraw and hraw. Okay, let's run it, and then let's compare with what we got somewhere here. Okay, so that's what we got from Python. And then we can say, so that seems correct. ZP seems also correct. And DP seems good. NP seems also good. DM seems quite good. NM is also not correct. So we screwed up in NM. Probably it was the expression with the minus in it, right? NM, yeah. So here we did something. Oh, I see it. Christ. That needs to be an N1. Okay. And now the end result is correct. Okay. So we got 0, 29599, 29599, 85843. Okay, so but we're only using 32 bits. So okay. So although we have no debugger, it's still we still got it. Okay, so okay. Um, no, I know that's not. I wanted to have. Okay, so
Jakub Cherzanovsky avocado. Good morning, Patrick saluting face.
good morning, Jacob. You missed the whole night. You shouldn't sleep so long. So I went crazy the last hour getting the debugger to run because it runs and it works, but I can't get into function calls. So I can't step into function calls, and it's bad. But I got text to speech. Restream has text to speech. I turned it on. Okay, so we got
Jakub Cherzanovsky avocado. I didn't waste it though, melting face.
that. So what did you do? Okay, so where is the implementation that we need? Here we go. Okay, so now we have the scaling factor, and what we need next is just the filter.
Jakub Cherzanovsky avocado. I slept.
Yeah, that's good. I wasn't tired, so I had a quick nap on the couch, and then I don't know, maybe at 11 I woke, and then I was fit. So I thought I'd get this going. And it's actually pretty nice. It's okay, right? So the language server here that uses the LSP4j is pretty good. It gives a lot of stuff. So okay, so this gets, and now it gets a bit tricky. So this gets an array. I don't really know how we represent that because we need to get it from the image. Okay, if you're still here and your eyes are already open, I can show you what we're going to implement. Wait. We are going to, oh no, that's not it. Let me quickly try it. Yes. Okay. Here we go. We will start, we'll do something very simple. We will start from a random image, and then we will create a very simple filter that looks like that. It's really easy. And then it converges to something like that. But we can influence what it actually does in the end. Right, it depends a bit on what exactly we do. And if we Whoa, that's nice. And of course we can colorize it later. And it's really, really easy what happens here. So, and if we can do something like that. Yeah, so this is going, this is what we're going to do. So we need a X here, and probably it's not an X, I don't know. And this is going to be an array. And I need to see if we have an array, if an array has length, something like that. And probably a filter length, which is also that. I think I'm missing the function here. And it returns. We'll see. I think for that, we need to return a new array. Because otherwise, we cannot destroy the existing one. So, and I need to check. I have no clue how it works with pointers or references here. So we will do that later. We'll first implement it. And then, okay, so here I will simply copy this one. That's just constants that we need. And I think like this. And then we need to put this here. Perfect. Looks good. Okay. So we have this one. Okay, so const n0 is 0. I think it's just left over. Okay, and now it gets tricky again. Maybe not. I think it's everything is in reals here. Maybe we get away with it. Let's see. So in Python, it's like this. Okay, so, and we need to implement this first coefficient n1. As far as I can see, we should be able to just write it down. Let's hope for the best. Let's copy that here and do something like that. And then let's put it a bit on one line. So const n1. It starts with an opening and then like this. So this is, and I'm not sure why it has a, oh yeah, okay, so in Python we need that, here we don't. So no, I don't want it all on one line, please. Can I do that? Can I just say like this and it still works? Or we make it even better and say we make the cut here and then the cut here and the cut here, like this. Does it leave my lines alone? Yes, it does. Probably, I'm not sure why the indentation, okay, no. Oh, so this needs to go there. Where's this going? Oh, okay, let's do like that. Perfect, that seems to work. So, okay, so we can skip that. It's nothing hard. Then we need const n2. That coefficient will be this one here. Okay, also looks as it could work. So where is that? This, and then probably put these two here. Okay. Looks also pretty nice. Maybe like this. Oh no, there's no n4. There's only, okay, so now we need the denominators, the coefficients for the denominator, and no, it's all real. Every number is real. So now we get away with it. We can simply copy Python code. It's not too bad. Maybe like that. And const d2 is like this. Looks good like that. You're missing something. Oh, okay. So this is not allowed. It needs a white space. Does it? Okay. Maybe break here. Do like that, and then we have const d4 should be the last one, which is also pretty short. And okay, and now we need the scaling factor, const scaling, and this is normalization factor. So we got that normalization factor, and here we use simply n1 and 2 and 3 and 4 we have here d1, d2, d3, d4, and signed. And I think I got rid of that. Did I? I know, I think it's... So, that's the question. So we have here signed bool. Okay, let's put this like that. So That's the nominators, that's the denominators, and then we have sign bool, and can I do something like true? It's not possible, right? Okay. If it's not possible, we simply will say false. Okay, so now we got the scaling. And let's see. So that means the ends. So I think we don't even need n0. Let's keep it in just for a second. So this needs to be var. That needs to be var. And I don't know. Local variable is never mutated. No, not yet. And okay, so and here when we have the scaling factor, we need to say n1 is s scaling. Okay, and 2 should be divided by scaling, and 3 should be divided by scaling. Okay, we got that. So okay, now we need to, unfortunately, know how to work with arrays. Where is it? So here. Okay, documentation. We need arrays, arrays, arrays. Destructuring arrays. Okay. So okay, so there's no documentation, only this test arrays file. Iterate over an array. Initialize an array to 0, split 0. So I need to know the length here. So first I want to know if how we provide basically arrays as arguments, if we can use references or pointers, or we got pointers here, but what I'm really looking for is okay, so first let us create an array. So because we need now n is, did we call it x length? So we know the length, and now the question is, can we do okay, let's try it out. So first, and this has the type of array like this, and so what, how did it splat 0. The question is, can I say n here, or is that not possible like in C? Okay. Splat. Okay. I don't know if that works, but we will see. So, and we need, and also don't know if const means that basically the memory where the array is const, or if all the values inside the array are const. So we need to find that out. So ym is also of size n, right? And we need the same, whatever splat is. Splat 0.0, but it seems to initialize the array with zeros. Okay. Now we need a for loop like this. So for, God, let's see. For, nice. So we have 4 items. To access the index of iterations, specify a second condition as well as a second capture value. Okay. So we need to rewrite the code a bit. Is there a range like in Python, or wouldn't you do that? So there are 18 ranges. I hope they're not. Okay, looks good. Syntax. These are inclusive of both ends. Okay. So this is inclusive of both ends. Okay, let's see if we. Okay, so I should be able to say something like that, right? So we could say for and what do I need the first thing for? Can I do it like that? N -1. And here I just capture I think that's it, right? Okay, and let's try to let's try to copy the code from Python and see if I can fix it up. So yeah, what we should do here is definitely put a semicolon in the back. So this needs to be reversed. So I say const, and here I think it needs to go that way. So if we do that, else that, so we put parentheses around here. That should do the trick. Okay, let's first put parentheses. Okay, and then we can hopefully, so this needs to go, and let's get rid here, and then we can take, I think, everything. So just go here. No, why does it skip it? Okay, so I don't understand. So I got the X. No, that's wrong. Maybe it's because of the error. I don't know. It's possible that selection doesn't work because of the error. So let's get rid of that. Go here and insert it. Okay. Okay. Like this. And then no, it's not const, of course not, because it's already defined. And we should be able to say this. Okay. And that's the forward path through the one-dimensional array. So, okay, yeah, let's put that down. Of course not. Forward pass and then we got here a backward path of the filter. Okay, and then we can say the same thing, right? Right, okay. No. Okay. Whew. I thought my computer died. It didn't. So I grabbed something to drink. I'm back in 1 second. So let's do like this. Wait, how can we do it? Like that and like that. Alrighty. Okay, so before we continue, we can quickly assemble the 3D printed stuff because that's done. The printer's ready, so let's move over to here. Okay.
Boston 45. Do you also do 3D printing?
Wait, I didn't get it. I don't have to. Loud. Yes, I do 3D printing. It's really nice. It's really awesome. You can build so much stuff. So, for instance, this is a custom holder for my brother for some electronic stuff, and you can basically just I don't know, just put it here, and then there's a sensor that comes here, I think. And we fiddled around a bit, and I think this seems to work. So and we build it like that we can, that it basically then this can be printed like this from bottom to top. And then you have these clamps down here that can be printed from bottom to top, and then I just have to glue them together. You should see that, right? So yeah, basically you have holes here, have holes here. I glue them together and put a pin in there, and the glue, the plastic glue that you're using, that's so strong. I said before, right? I think before the clamps break, the whole thing breaks first. It's really, really strong. And 3D printing is not really that difficult, right? I also started from zero. I had no clue, maybe a year ago or something. And I just thought, okay, I need a printer and I want to try something out. Okay.
Boston 45. Yeah.
Do you hear yourself? So when you write something, do you hear basically the echo? Because I have it on loudspeaker, or is it okay? Okay, see, and that's all that's needed. Usually I put
Boston 45. It okay, no echo.
Okay, perfect. Because now I'm also using the room microphone. Otherwise you wouldn't be able to hear me. Okay, let's put that together here. Just have to be a bit quick with the glue because it's once it gets under pressure, it's really tight.
Boston 45. I want to make my Warhammer 40k figurines.
Yeah, I mean, these are easy, right? Because you'll most likely find lots of models for that.
Boston 45. With 3D printing.
Yeah, so I can show you, there's lots of models online that you can just simply download and print without doing anything. So this part is basically the top part here that was available already. So we used that because we knew it would fit exactly the sensor. And the rest of the bottom part here, we designed ourselves. Okay. Okay. Number 4 done. Yeah, so I do things like famous stuff or things that exist. You can go to usually I go to Maker World. And then you can, so what do you say, Warhammer 40k? I don't know, heard of that. Okay. So I mean, so printing in several colors is possible, but it takes a lot of material, right? Because basically you print the thing from bottom to top, slice by slice, right? You start. I mean, I can show you. Just show you. It's much easier that way. Let's. When at some point I point at something and show something and you don't see anything, then it's me.
Boston 45. It would be to make them a flat color for a single material and then without painting them. Broston 45. I can't hear you. Broston 45.
Right? That
Ha
is,
ha ha ha.
yeah, that's the right move. So if you can't hear me, you need to say something. When I switch to that, when I switch to that view where you see the desktop, I have the other microphone turned off automatically. So, okay, so if you, so for instance, this figure, right? So I have a Bamboo Lab printer, and this is Bamboo Lab Studio, I think is the name. And so you can just download the model, right? And then you have basically, these are two plates that you need to print, one for the chassis and one for the rest. And right, and you can do, so it's a bad example. I wanted to have something that is basically a whole one figure, right, that you print from bottom to top, but it doesn't matter. I can show you. So and then you need to slice it, right? And slicing means you really divide the model into slices and also into lines that the printer will follow, and I can show you that. So if we go really close here, like for instance here, right, you see that the oh god, that the model is really made out of lines. So we start and you print it from the bottom. So this is basically the first thing you print, right? And I can show you also, so the printer starts like that. Wait, here, right? It would go here, then go around, and then it would print that. So basically like drawing with a pen on a piece of paper. And once you did this, the first layer, right, it moves up one layer. So, and then it moves up another layer and another layer and another layer. So, and if you want several colors, the printer has to, the normal printers, they have to switch the color in the nozzle, right? So they need to, first, they need to push out the material out of the nozzle so that you can get the next color in. So you waste a lot of material. And usually what happens there is they build basically a fake tower on the side where they print all the material that goes to waste just there, right? And then you have, and every time basically you need to switch the color in between. It needs to clean the nozzle and put the other color in. And that uses a lot of material and it takes considerably longer. So my daughter is doing masks, and she so I bought an airbrush for her so she can spray it, and this is perfect for such models, right? A small airbrush with a compressor and colors, and you mix it, and you have a filter, a bigger one where you can sit before and you can just spray and colorize it. It's awesome. Yeah. So right, and then you basically so I didn't know any of that, right? And then you have basically this program, and so first you either you import a model or you create a model yourself. You can do that. There are several programs. Tinkercad is really easy to do, but also very basic. And then you have parametric programs. FreeCAD is a free one that you can use, and basically you create the models there, right? And then you can just import the models like this. And if we go home here, recently opened, can I show you? Let me show you something that I did. So for instance, and that's something I built completely myself. It's just a cover for my camera, right? And it's really, it's easy. It looks easy, and it was easy. And the only thing that's a bit time consuming is to get the measurements completely right. So if you want to have, for instance, small pins, right, that go into holes, there needs to be a tiny gap, and you want it really to fit, right? So it takes some prints to test this out, but otherwise it's really easy. So, and then you have the model. Then you can make all the adjustments you like. So for instance, if we look onto this thing. Let's make it not strength, but use something like draft, and we slice it, and probably we should use a different color. Wait, I want something bright. Maybe that. Okay, yeah, that's good. So, and you see, basically, you can completely customize how much material goes in between, right? So the things that you don't see, this decides basically how strong the material is, right, after printing. And yeah, so these are the things that you set here, and you can say, okay, I want the top layer to be really, really perfect. So it starts to make it very, very slow and with much finer lines, right? What else can you do? So this is the strength stuff. You can decide what kind of filling pattern you want in here. And sparse infill, you can say, okay, how many percent should be the infill. It all comes down to, okay, you want to make the print perfect if you want that. Otherwise, if you don't care, just select something, and then you slice it. And slicing, as I mentioned, means you have your model in a way that the 3D printer can move the nozzle and print out the stuff, right? And this consists of basically the lines. And what you see here on the side, on the right side, what goes down is the G code. That's exactly the movement information for the printer. So, and then you see basically how the nozzle move or would move if you print it. Yeah, and then you go print. You just print it and you're done. So, and there's a bit of stuff that you need to pay attention to, like I got a system where I have the ability to have 3 different colors in one, let's say, filament provider, right? And it can switch the colors automatically. And
Broston 45. UFFF, that's a lot of lines for
yes,
one layer.
Yes, it is, right? And it's really amazing that the print looks really good, although it goes so fast, right? So this is a very small model, right? And you can see it really goes crazy. And then if you take something in between, yeah. So you're right. It's really amazing that it works so well. Yeah, so you need to keep the filament, that the stuff, the material that you use for printing, that needs to be somewhat dry. So there are many different kind of materials you can use. So the easiest one is called PLA. It's a plastic. It's the one that I showed you before. It prints really nice. It's not complicated at all. It doesn't need special treatment. It doesn't create toxic fumes or stuff, right? But then you can also print, for instance, more elastic materials or very strong materials that also don't break down if they are, I don't know, 10 years outside in the sun or something like that. Yeah, but just to get something started, it's easy. You weren't here before, Person, right? Because I wanted to show you what we're actually going to try to do with the program, because I already have it, right? I just don't have it in Zig and as a program. I just have it in Mathematica. So what we're going to do is to create this visualization here, that one. So, and we are probably more aiming for something like this. That's what we're going to do. And that's why we need the stupid gradient filter. And and if we get along pretty well and make progress, then we can also do a colorized version like this. What did we use? Sunset was good, right? This is what we're aiming for our first small, we have no clue program.
Broston 45. That's incredible. What program is that?
So that thing is called Mathematica. What you probably know is Wolfram Alpha. Maybe you have heard it, maybe not. I'm not sure how much it is used nowadays, but you can basically ask it anything. So for instance, I don't know, all kinds of stuff. I don't know, let's just click here on something. So maybe something like that. So the expanded form, so something from school, right? And it gives you plots and it can show you lots of mathematical stuff. So, or you can integrate stuff, but you can also ask it things. So basically, but that's Wolfram Alpha. And for a very long time, since, I don't know, 1980 something, 9, 7, not sure, maybe even before that, they have a program called Mathematica. And Mathematica is, it's called a computer algebra system. So what it's really good at is to do calculations, right? So, I mean, it can do arbitrary precision. So if you have something like factorial of 100, oh, that's probably, so it can really, it doesn't matter how long the expression gets, right? It can do it correct. And I mean, I'm not sure what your background is, right? I don't want to show you something and then you say, oh, I don't understand. Oh, I have never seen that, right? But if you have, for instance, I don't know, in school, you got something like, let's say x minus 2 squared minus 3, and you plot that. Something like this, right? And if we go a bit further here, let's like this, and here to 10, you see that it's a parabola. And in school, often you needed to calculate the crossings, right? The roots where it crosses the x-axis. So, and you can do something like that in Mathematica pretty easy. So you wanted to find that, and then you can just say solve for x, and it gives you the answer in a correct way, right? No numbers. I mean, of course numbers, but it gives you
Broston 45. Ha ha ha, don't worry, I'm trying to learn everything I can.
Yeah, that's a good, that's spirit. So, and it can basically help you understand things.
Broston 45. English 2.
Yeah, I mean, you hear that I have an accent as well, and I'm working on that. And the only thing you can improve is by talking. And even then you need, right, you should not fall into the trap of just doing what you always do. You need to try to improve all the time. And if you have a mistake or you say something wrong, then try to understand what you do. Yeah. Okay, so that is Mathematica. And one of the strengths of Mathematica is that it can do really amazing visualizations, right? So for instance, if we have a function and the function gets an x and a y, right? So just on the Cartesian grid. And it gives back one number, and we just say something like, I don't know, sine x plus y, and maybe times cosine x. It's nothing special, nothing to do. So then you can pretty easily just plot it. Just to say, just plot the function f we just defined from x, I don't know, -2 to 2, and y -2 to 2. There you go. So, and this is basically where you would use a computer algebra system. So you would use it if you have very hard calculations and expressions
45.
that you need to do,
Wow.
or you would use it if you need to understand something and you need visualization for that, right? Or complex integrals and so on and so forth. So 30 years ago or 40 years ago, or even, I don't know, 20 years ago, you probably would sit down and have to solve lots of stuff by hand, right? And that's where a computer algebra system comes in very, very handy. Okay, and this, and here, right, and it doesn't only do calculations, it also can work with images and stuff. And yeah, so that's why this works. So wait, I wanted to, so we have sunset colors, and we got another set of colors that I liked very much. Deep sea lake, mint, rainbow. No, 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 no. Starry night. What is starry night? Yeah. Yeah, that's what we're going to do. I'm so happy that my text-to-speech works. 1 second. Okay. Since we want to make progress, let's continue making some progress here. So we're on the backward path of the filter, and so let's quickly check. So I hope it's 0 indexed, because otherwise it won't work. So we go to n-1, and that should be fine. And then we assign it to yp. Okay, that's good. So now we go to the backwards path, and here we have the following. So we need m1, and that's just negative n1. Okay, I think we need m2, and that's just negative n2. And do we need m4? Why is it working? Oh, I used n0. So we can get rid of the whole thing. Is that used anywhere else? No, it's not. Okay, let's keep it in. I know that the Python code works here. So then M3 is minus N3, and M4 is just 0. And probably, so, okay, so can I do something like that? No. So this is comp time float. Let's define it like F32, like this. So that's the same type. I'm not sure. I'm pretty sure it gets it, but we'll see. Okay, and then we have the same for loop. So we did something like for 0 to 0 to n minus 1. But the thing is, okay, so I don't know. Can we do something like from 4 to 1? Does that work? Okay, so we need to check again. So where do I find range? So range is here. Okay, it iterates upwards. Is there a version? To iterate over consecutive integers, use the range syntax. Okay. I did that. 4. What if I need to go downward? Items. From 1 to 6, from 1 to 6. The question is, where do I, so it's 3 dots. Okay, so it's 3 dots, and something is wrong with the 3 dots. What? 1, 2, 3. Ranges can be specified using the 3 dots syntax. What? I used only 2. Oh, this is probably wrong. Expected comma after operand. What? Now I'm confused. Okay, wait. There are 2 ranges. Now it's only 3. No, only 2. Test 4. What? Use the range syntax. Ranges can be specified using the ... syntax. So probably this is only for booleans. So if I say if okay, okay, that's not an equal. Okay, so that is okay. So that's probably only for switch statements, and it's not a real range. Is there a sig rebel? REPL for sig. A sig playground. Okay, let's see if that works. Can I simply print something like that? Is that possible? It doesn't look good, at least. Run. What's the syntax here? Like this. Like that. Get rid of that. Okay. So that works. The thing is, we needed to know if the other way around does also work. So run. No, it's not. Error overflow integer. I would really like to see where this thing is defined. Overflow of integer type usize. Okay, so yeah, it shows an overflow because it tries to go upwards from 5 to 0 until it wraps around, and then we have the overflow. Okay, I get that. So can I get it to count down without doing it manually is the question. What I'm wondering is if that thing has a name. So I can do something like that. Like this. So does that thing have a name? No. Sig operators dot dot. I'm here. Okay, so not bookmark dot dot. Okay, so this will not lead to something useful. So this is obviously possible. Test modify an array. Some integers. Where's some integers? Oh, here. So, okay, so we know we can go, basically we know the endpoint, right? So we go back to the playground and we say const array is of type, I don't know, 10 of type U8. And then there was something like splash. Let's say 1. Okay, and okay, how was the so here's the thing. Okay, so the for syntax is not really clear to me. So we can give obviously the reference or the pointer of the array, then a comma, then 0 to something, and we do get okay, so this syntax is pointer dot star. Maybe it's the okay, we need to check what dereferencing and pointers how they're used. Row and row index. Okay, so we definitely need that later. Okay, let's go with the least resistance and say we do it like this. And here we go from 1 to n, call it I, and then we say const, we call it index, and we say const I is the same as n minus I, minus index, sorry. And then we can continue. Then we got the right, I think we got the right index. Okay, and then we can basically say, let's take all that. Of course, not like this. Like that. So first thing we need to do is again fix these things here, and we go there. Then we can copy, not copy, cut all these out. Ah, Christ. No. So we want to have this one. So let's go to the end. We need semicolons, and here we want that X, and we want to put it here. So if this is, so let's recap. So if I plus 1 is bigger than n, then okay, so just the boundary conditions here. And I want to know if so this is really weird, right? Why can't it go upward the, I don't want to have this whole block. Let's make a quick file here. Say file and call it improvement plugin improvement suggestions MD. Okay, so first structural selection doesn't work too well, and too quick. Okay, so this is, so then of course we have the pain point with the debugger. That one should probably first, because we need to find out. So why am I not allowed to jump into subcalls or function calls, or why do breakpoints in function calls don't work? Yeah. Okay, so this is on us. I'm pretty sure I'm doing something really wrong here, but I don't know how to fix it. Okay. Right, so now we got that. These need to be constants. Okay, perfect. So we got that. All right. So I think that this is not going to work, at least from what I saw, because I declared it with const. So, but the compiler will scream at us. So the only thing that's missing now where is this brace? Oh. Okay, so the only thing that's missing now is to return from the function. And we can't do it as elegantly with list comprehension, I think. So we'll need another for loop. Right, so it was so how okay, so now I can do it actually. So for ym, this is not going to work like this, but we'll see. Maybe for ym, okay, then I can say value I maybe it works, I don't know. And then I say ypi is the same as value. Okay, so now the thing is, if I say return who owns the memory here, I have no clue. Let's hope the compiler helps us. Okay, so we get an input array. Not sure how this is done, and we need to read if that's copied or if there's a pointer or a reference. We just access it, we never change it. We create two new arrays, one of which we need to get rid of again. So first, let's just try it out, and then we'll see. So let's say here, let's call it x, and x is an array of, let's say, 256 values of f32, and we initialize it with splat. Okay, and then we say for okay, let's be, it's just we need to get better at that. And then we say xi is the same as I don't know, does casting happen here? Let's see. Okay, and then we want to say output is the same as filter dot that x goes in and let's say sigma 0 to 5. Okay, now all right, so comp time float here. Okay, so that's what I thought. Let's see how we cast. casting. Type coercion occurs when one type is expected, but different type type is provided. Okay, I understand, but as no const to const is allowed. Okay, okay. So I think we should first use as. So here I say as F32 and I. Okay, good. So 2 errors. Why? What? Expected type after found use size. I know. Error. Expected type is F32 and found use size. So okay, int to float. Int from float. Okay. Is there also an int to float? What? Cast 5 to comp time float, resulting in as comp time float 10.8, which is casted to as optionals. No. Okay, so that's all casting? No, it can't be. A typecast converts a value of one type to another. Zig has type coercion for conversions that are known to be completely safe and unambiguous, and explicit casts for conversions that one would not want to happen on accident. Pure type resolution for the case when a result type must be decided given multiple operand types. Okay. So So what? So I can't write as. Okay, so what does as? Okay, so first let's look at explicit casts. Bit cast, line cast, error, float cast. Converts a larger float to a smaller float. No. Float from int. Convert an integer to a float value. That's what we probably want. Convert an integer to closest floating point representation. Return type is infinite. Okay. To convert the other way around, use round or whatever. Okay. So float from int. Float from int. And that's usize. Okay. Okay, how? What?
Broston 45. My mind doesn't give any more at this time of night, ha 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 ha.
Yeah, so here it's, I don't know, 7:40 in the morning. Where are you located, Broston? You're in the US?
Broston 45. I am from Colombia.
Colombia.
Broston 45. Where I live, it's already 1 a.m.
Yeah, so I'm over that point already. How's the weather there? It should be pretty nice, should it, right? I mean, not now. Now it's dark, I guess, but
Broston 45. Depends of region.
where you live, is it sunny during the day already? So for us, it's, I mean, it rained yesterday a bit, but otherwise it was pretty awesome
Broston
weather.
45. Where I live, it's pretty cold.
It's pretty cold, really. But okay, so but how? So wait, let's see. So this should be the equator, right? Um, no matter where you live, you're really close to the equator. But I understand that right now it's almost summer for us. For me, I'm located here in Germany, so the sun should be high up. But maybe you have a different definition of cold, right? Because so cold for me is negative degrees Celsius. So I think right now it's probably 25 Celsius, uh, which is 77. And this is pretty warm for me.
Broston 45. Yeah, ha, for me cold is 12 degrees.
Okay. Fahrenheit or Celsius? It's difference, right? A big one.
Broston 45. Or less, but degrees is very cold.
Mhm. Okay, so Zig. Float from, was it float from int? Float from int. The built-in function converts an integer value to closest floating point representation. Okay. But Okay, so I need that. So as, come on, but it's not possible, right? It's not possible that I need to do a double thing. So like this, F32. It does know already that this is going to be an F32 type. Why do I need this? I'm doing something wrong, I'm pretty sure. So, okay, so we can't do that. And I think the trick that people using Zig is to get rid of the second error, that unused local constant, is like this. Just use it and don't use it. Okay, compilation error. Okay, error, cannot assign to constant. Okay, so was that the error before? No, it wasn't, right? So here we need var. Okay. So then we should have several of these. So array literally requires address of operator to curse to slice type. Okay. That was one of the things we needed to look up. Anyways, so we got arrays here. And we want to know what exactly it means to have an array. And maybe we find it under functions. I don't know. Okay, so pointers. Zig has two kinds of pointers, single item and many item. So star T, single item pointer to exactly one item. Supports dereferencing. Okay, so that was what we thought before, that this is dereferencing. Supports slice syntax. Okay. Supports pointer subtraction. Okay. So then we have this syntax here. Many item pointer to unknown number of items. Okay. T must have a known size, which means it cannot be any opaque, okay, or any other type. Okay. So you need to know the byte size of the, or the bit size of the type of the underlying. That's understandable. So these types are closely related to arrays and slices. Okay, so there's obviously a difference between slices and arrays. So pointer to n items, same as single item pointer to an array. It's a pointer to n items. Okay, supports index. Okay, is a slice, a fat pointer which contains a pointer of the type and the length. Supports index syntax, supports slice syntax, supports length property. Okay, let's see if we find something here. So we have x. X is just a number, and then we have a pointer to x, which we get with the ampersand. Which, okay, yeah, here, use ampersand to obtain a single item pointer. Okay. So this has some similarities with C. Pointer array access. Taking an address of an individual element gives a single item pointer. This kind of pointer does not support pointer arithmetic. Okay, oh god, it's complicated. So we have a fixed array. And then we can say yeah, wait, give me 1 second. All right, I'm sorry, we need to take a break. Emergency. Thanks everyone for stopping by.